Hello there, and welcome. Tonight I want to take you somewhere extraordinary, somewhere that exists at the very edges of imagination and possibility. Come, settle in wherever you are right now, whether you're tucked beneath warm blankets or resting against soft pillows, whether the night has already drawn its quiet curtain across your window, or whether you're stealing this moment of peace in the gentle light of day. This is your time, your space, and I'm honoured to share it with you as we embark on a journey that will carry us to the furthest reaches of everything that exists, and perhaps, just perhaps, to a place where you could reach out and touch the very edge of the universe itself. I wonder where you are right now as these words find you. Are you listening from a busy city where the lights never quite let the stars through, or are you somewhere quiet where the night sky opens up like an ancient book above you? What time is it where you are? Is it that perfect hour when the world seems to pause, when thoughts become softer and the boundaries between waking and sleeping begin to blur? Wherever you are, whenever you've found this moment, I invite you to make yourself comfortable, to let your breathing slow and deepen, and if you feel moved to do so, to leave a gentle trace of your presence here. Perhaps a soft like, a quiet subscribe, a small note about where in this vast world you're listening from. Think of it as dropping a pebble into a cosmic pond, creating ripples that connect you to others who are also wondering, also drifting, also seeking that peaceful space between questions and dreams. We're all fellow travellers here after all, each of us carrying our own quiet curiosities about the universe and our place within it. Tonight's journey begins with a question that might sound impossible, even absurd at first. What if the universe had edges you could actually touch? Not metaphorical edges, not philosophical boundaries, but real, tangible limits that you could approach, reach toward, and gently press your palm against, feeling the ultimate boundary of everything that exists. It's a question that seems to defy everything we've been told about the cosmos, everything our science textbooks assured us about the nature of space and time, and yet there's something deeply human about wondering where things end, about imagining that somewhere, somehow, there must be a final frontier, a last shore where the ocean of existence meets something else entirely, or perhaps meets nothing at all. You see, we live our entire lives surrounded by edges and boundaries. The walls of our rooms create edges between inside and outside. Our skin forms the boundary between self and world. The horizon draws a soft line between earth and sky, though we know it's just an illusion created by the curve of our planet. Even our days have edges, the gentle boundary of dawn, when night yields to morning, and the soft threshold of dusk when day surrenders to darkness once again. We understand our world through these limits, these meeting places where one thing ends and another begins. So perhaps it's only natural that when we look up at the vast darkness above us, sprinkled with its countless stars, we can't help but wonder, does it all have an edge somewhere? Is there a place where the universe itself comes to an end? The scientific part of our minds immediately protests, doesn't it? We've been taught that the universe might be infinite, stretching on forever in all directions without boundary or limit. Or if it is finite, we've learned it might curve back on itself like the surface of some unimaginable sphere, where you could travel forever and never reach an edge, just as an ant walking on a balloon would never find a place where the surface stops. These are the explanations that make mathematical sense, that fit with our observations and equations. And yet tonight, I want to invite you to set aside that certainty for just a while, not to abandon it, not to reject it, but simply to place it gently to one side, like setting down a heavy book you've been carrying, so that your hands are free to explore something different. What if we allowed ourselves to imagine, just for these quiet hours, that somewhere out there, impossibly far away yet somehow still reachable, there exists an actual edge to everything? Not a violent boundary, not a wall or a cliff or a sudden ending, but something softer, more mysterious. Perhaps it's like the edge of a dream, where images begin to fade and blur before dissolving into the darkness of deep sleep. Or maybe it's like the edge of a piece of music, where the last note hangs in the air for a moment before silence reclaims the space. What if the universe has edges like these, gentle, touchable, yet profound in their finality? As you lie there listening, I want you to feel how your body rests against whatever surface supports you. Feel the gentle pressure of gravity holding you to this world, this small blue sphere that spins through the darkness. You are, right now, at a very particular location in the universe. You occupy a specific point in the vast three-dimensional space that extends outward from where you are in all directions. Above you, below you, to every side, space continues its expansion, carrying galaxies and stars and worlds beyond counting. And somewhere, according to our gentle thought experiment tonight, somewhere in all that vastness, there are edges waiting to be discovered, boundaries longing to be touched. This idea of touching the edge of the universe might seem like pure fantasy, and in many ways, it is. But sometimes fantasy serves a purpose beyond mere entertainment. Sometimes, imagining the impossible helps us understand the possible in new ways. When we picture ourselves approaching the universe's edge, when we imagine reaching out our hand to touch that ultimate boundary, we're really exploring what it means to be finite beings in what might be an infinite cosmos. We're investigating our deep human need to understand limits, to map territories, to know where things begin and end. And perhaps most importantly, we're acknowledging that sense of wonder that rises in us when we contemplate the vastness of existence and our tiny but meaningful place within it. Think about the first humans who wondered about edges. Long before we understood that Earth was a sphere floating in space, our ancestors must have looked toward the horizon and wondered what lay beyond it. Some imagined that if you travelled far enough, you'd reach the edge of the world, perhaps a great waterfall where the oceans poured off into an infinite void. Others thought the sky was a solid dome, a crystalline sphere that held the stars in place, and if you could somehow climb high enough, you could touch it with your fingertips. These ideas seem quaint to us now, almost childlike in their simplicity. But weren't those early wanderers asking the same fundamental question we're asking tonight? Where does it all end? What lies at the boundary between what is and what isn't? As we prepare to explore this question together, drifting deeper into the mystery with each passing moment, I want you to understand that this journey isn't about finding definitive answers. We're not going to solve the ultimate riddle of the cosmos tonight. Instead, we're going to do something perhaps more valuable. We're going to wander together. We're going to let our imaginations drift outward like cosmic explorers, moving through the darkness between stars, sailing past galaxies and nebulae, always heading toward that imagined edge where we might, just might, discover something extraordinary about the universe and about ourselves. The universe, as we currently understand it, began about 13.8 billion years ago in an event we call the Big Bang, though that name doesn't really do justice to what happened. It wasn't an explosion in space, it was an explosion of space itself, a sudden emergence of everything from a point of infinite density and temperature. In those first moments, the universe was smaller than an atom, then rapidly expanded, cooling as it grew, allowing the first particles to form, then atoms, then eventually stars and galaxies, and all the cosmic architecture we see today. But here's where our question becomes particularly interesting. If the universe began as a point and has been expanding ever since, doesn't that suggest it has a size? And if it has a size, doesn't that mean it has edges? You might be lying there thinking, but wait, I've heard that space itself is expanding, that there's no center and no edge, that every point in the universe sees itself as the center of expansion. And you'd be right to think that. This is what our best theories tell us, what our observations seem to confirm, but tonight we're not bound by those theories. Tonight we're free to wonder, what if there's something our theories haven't captured yet? What if, beyond the observable universe, beyond the cosmic horizon that limits what we can see, there really is an edge, a boundary, a place where the expansion stops and something else, or nothing else, begins? Imagine for a moment that you could travel faster than light, that the usual rules didn't apply to you. Imagine you could journey outward from Earth at impossible speeds, watching the stars blur past, seeing galaxies shrink to points of light and then disappear behind you. You travel for millions of years, billions of years, always heading in the same direction, always moving toward the edge. The universe around you would change as you travelled. In the beginning, you'd pass through regions much like our own, filled with galaxies and clusters of galaxies, vast webs of dark matter holding everything in its cosmic pattern. But as you continued, things might begin to change. Perhaps the galaxies would become sparser, the darkness between them growing larger and emptier. Perhaps the very fabric of space would begin to feel different, like the change in air pressure as you climb a tall mountain. And then, After travelling for a time that defies comprehension, you might begin to sense something ahead of you. Not see it exactly, because perhaps the edge of the universe isn't something that reflects light in any ordinary way, but you'd feel it somehow. The way you can feel the presence of a wall in a dark room, the way you know when you're approaching the shore even with your eyes closed. The edge would announce itself not with fanfare or drama, but with a subtle shift in the quality of space itself, a gentle suggestion that you're approaching something unprecedented, something that represents the absolute limit of physical existence. What would such an edge look like? This is where our imagination becomes our greatest tool, because we're trying to picture something that by definition exists outside all normal experience. Perhaps the edge appears as a gradual fading, where the darkness of space slowly becomes something else, something that isn't darkness, because darkness implies space in which light is absent, and beyond the edge, there might not even be space for darkness to exist within. Or perhaps the edge is more defined, a surface of some kind, though not made of any material we could name. It might shimmer with the last light of existence, a boundary that glows with the accumulated energy of every photon that has ever reached it, creating a wall of soft radiance that marks the end of everything. In some of our dreams tonight, the edge might appear as a mirror, reflecting the universe back on itself, showing you the entire cosmos from a perspective impossible to achieve from within it. You'd see every galaxy, every star, every world laid out in an infinite tapestry, and somewhere in that vast reflection, impossibly small but undeniably present, you'd see Earth, and on Earth you'd see the very spot where you're resting right now. Listening to these words, dreaming of edges and boundaries. The recursive nature of this image, you looking at the edge that shows you looking at the edge, creates a kind of peaceful paradox, a gentle loop of observation that somehow feels right for the boundary of everything. Or perhaps the edge is permeable in some way, not a hard barrier but a soft transition, like the place where ocean meets atmosphere. You could push through it, feeling resistance that isn't quite physical, experiencing a sensation that has no analogue in our ordinary experience. And as you pass through, what would you find on the other side? Nothing, in the most literal sense. Not empty space, because space is something, but true nothingness, an absence so complete that even the concept of absence doesn't apply. Or would you find something else entirely, another universe perhaps, or a realm where the laws of physics are different, where time flows backward or sideways, where consciousness and matter are reversed in their roles? These are the kinds of questions that philosophers and physicists have pondered in their own ways, using logic and mathematics as their tools. But tonight we're using imagination and wonder, and these tools sometimes take us places that equations cannot reach. When we imagine touching the edge of the universe, we're really exploring what it means to be conscious beings capable of imagining anything at all. We're celebrating the strange fact that the universe has evolved creatures like us, who can contemplate the universe itself, who can wonder about its limits and edges even though we're trapped on a tiny world, orbiting an ordinary star in an unremarkable galaxy among billions. The gentle pull of sleep might be beginning to work on you now, and that's perfectly fine. In fact, it's wonderful. Because as consciousness begins to soften and blur around its own edges, you become more receptive to the kind of truths that don't arrive through logic but through feeling. The edge of sleep and the edge of the universe have something in common. They're both boundaries between the known and the unknown, between experience and mystery. And just as you trust yourself to cross the edge into sleep each night, knowing you'll return safely to waking, perhaps we can trust ourselves to imagine crossing the universe's edge, knowing that the journey itself, not the destination, is what matters. Let me paint you a picture of how it might feel to approach this cosmic boundary. You're floating now, weightless and free, moving through space not with violence or urgency, but with the gentle inevitability of a leaf carried by a slow river. The stars around you have become sparse, just a few distant points of light in the vast darkness. You've left the last galaxies behind millions of years ago, and now you're in the true void, the empty space between the last outposts of matter and energy and the edge itself. It's quiet here, quieter than anything you've ever experienced. Not just the absence of sound, because sound requires a medium to travel through, and you've long since left any medium behind, but a deeper quiet, the silence of a place where nothing has ever happened and nothing ever will. And yet, you're not afraid. There's something deeply peaceful about this emptiness, this approach to the ultimate boundary, you realize that every journey you've ever taken has been practice for this one. Every time you've stood at the edge of something, the edge of a cliff looking out at the ocean, the edge of childhood looking toward adulthood, the edge of waking looking towards sleep, you've been preparing yourself for this moment. The universe has edges because you have edges, or perhaps you have edges because the universe does. Either way, the boundary ahead of you feels familiar, like coming home to a place you've never been but always known. As you draw closer, you begin to notice that the edge isn't uniform. It has texture, variation, patterns that shift and change as you watch. Sometimes it seems to pulse with a slow rhythm, as if the universe itself is breathing, expanding and contracting, in a cycle that takes billions of years to complete. Sometimes you see what look like currents or flows along the surface, streams of something that isn't quite matter or energy but partakes of both, creating patterns like the aurora borealis but on a scale that dwarfs galaxies. These patterns are beautiful in a way that transcends ordinary beauty, because they represent the fundamental structure of existence itself, the final expression of whatever laws or principles govern the cosmos. You reach out your hand now, moving it slowly through the nothingness toward the edge. There's no air to resist your movement, no temperature to feel, no sensation at all until the moment your fingertips make contact. And when they do, what happens then? The sensation is unlike anything in your experience, yet somehow you have words for it. It feels like touching the surface of still water, but water that exists in more than 3 dimensions. It feels like the static electricity before a storm, but gentle, welcoming. It feels like coming to the end of a beautiful piece of music and finding that the silence that follows is part of the composition. It feels like the moment between breaths, extended indefinitely, peaceful and full of potential. Through your fingertips you sense something vast and incomprehensible, yet also intimate and familiar. The edge knows you, recognizes you as part of the universe it contains. You understand in a way that bypasses thought and arrives directly as feeling that the edge isn't really a barrier at all. It's a membrane, a skin, a boundary that defines the universe not by excluding what's outside, but by embracing what's within. The universe needs its edge the way a song needs its ending, the way a story needs its final word, the way you need the boundaries of your body to define who you are. Without the edge, the universe would be incomplete, undefined, unable to know itself. This is the gift of imagining the impossible. It returns us to the possible with new eyes. When we picture ourselves touching the edge of the universe, we're really discovering that we're already touching it, in a sense. Every moment of consciousness is a point of contact between the finite and the infinite, between the known and the unknowable. Your thoughts right now, as you listen to these words and let them paint pictures in your mind, are performing the same kind of magic we're imagining at the cosmic edge. You're taking the raw material of existence, atoms and molecules and electrical impulses, and transforming them into meaning, into wonder, into dreams of touching something that might not even exist. But what if it does exist? What if, somewhere out there, beyond the reach of our telescopes and spacecraft, beyond the cosmic horizon that marks the limit of the observable universe, there really is an edge? What if future scientists, with tools and theories we can't yet imagine, discover that the universe does indeed have boundaries, that our cosmos is like a vast bubble floating in something larger, something that defies our current understanding? The possibility, however remote, adds a delicious uncertainty to our cosmic picture. It reminds us that for all our knowledge, for all our sophisticated theories and observations, the universe might still surprise us. It might still have secrets that would fundamentally change how we see everything. This is why we wonder, why we imagine, why we let ourselves dream of impossible things like touching the edge of the universe, not because we expect to find literal edges out there in space, but because the act of wondering changes us. It makes us larger on the inside, more capable of containing paradox and mystery. It prepares us for whatever discoveries await us, whether they confirm our current theories or shatter them entirely. And perhaps most importantly, it connects us to every human who has ever looked up at the night sky and wondered what lies beyond the farthest star. You're part of a tradition that stretches back to the beginning of human consciousness, a lineage of wanderers and dreamers who have always pushed against the boundaries of the known. The shepherds who named the constellations, the astronomers who mapped the movements of planets, the physicists who discovered the expansion of the universe, the children who lie on their backs in summer grass and ask impossible questions about space. You're connected to all of them through this shared curiosity about edges and limits and what lies beyond. Tonight, as you imagine touching the edge of the universe, you're adding your own thread to this vast tapestry of wonder. The edge we're imagining might not exist in any physical sense, but it exists in another way that might be just as important. It exists as a concept that helps us think about totality, about completeness, about the difference between something and nothing. It exists as a meditation on limits and transcendence, on the boundaries that define us and the imagination that lets us cross them. It exists as a gentle reminder that even in an infinite universe, or especially in an infinite universe, we need to create edges and boundaries to make sense of our experience, to create meaning from the vastness. As this first chapter of our journey draws toward its close, though our exploration is really just beginning, I want you to hold on to this image of the edge, not as a scientific hypothesis or a philosophical argument, but as a feeling, a presence at the back of your consciousness. Throughout the rest of our time together, we'll explore what this edge might mean, how it connects to real scientific discoveries and observations, how it relates to the actual structure and history of our cosmos. But we'll always return to this simple, powerful image, you, floating at the boundary of everything, reaching out your hand to touch the ultimate limit of existence. The universe stretches out behind you, 13 billion years of history, billions of galaxies, countless stars and worlds, all of it contained within the boundary you're touching. And perhaps, in touching the edge, you're not just making contact with a boundary, but with the universe's way of knowing itself. Perhaps consciousness itself is how the universe touches its own edges, how it discovers its own limits and possibilities. Perhaps every time you wonder about the cosmos, every time you imagine impossible things like edges you could touch, you're helping the universe explore its own nature, discover its own boundaries, understand its own vast and mysterious self. So rest now with that thought, that image, that feeling. You're lying safely in your bed, in your room, on your small world, but you're also floating at the edge of everything, your hand extended toward the ultimate boundary. Both of these things are true in the realm of imagination, and imagination might be more important than we realize. It might be the tool evolution has given us to touch edges we can't physically reach, to explore territories we can't physically enter, to discover truths that can't be found through observation alone. The edge is there, waiting, patient as the universe itself. Whether it exists in physical space or only in the space of consciousness doesn't matter nearly as much as the fact that we can imagine it, approach it, touch it with the fingertips of thought. And in imagining this touching, this contact between human consciousness and cosmic boundary, we're participating in something profound, something that goes beyond science or philosophy to touch the very heart of what it means to be aware in a universe that might or might not have edges. Where are you right now? Not in the cosmic sense, not in the universal coordinates we were just imagining, but right here in the immediate geography of your own experience. Perhaps you're in a bedroom, walls forming a comfortable boundary around you, creating a space that's uniquely yours. The ceiling above you might be 8 feet away, maybe 10, close enough that you could touch it if you stood on a chair. The walls might be 15 feet apart or 20, or perhaps you're in a cozy space where you can almost reach from one wall to the other without moving. This is your immediate universe, the space you occupy right now, and it's the perfect starting point for understanding the almost impossible vastness that surrounds us all. From where you lie or sit, the floor beneath you extends to the walls, and beneath that floor there's more. Foundations, earth, bedrock, all of it pressing down toward the center of our planet. If you could travel straight down from where you are right now, passing through floor and foundation and soil and rock, you'd journey about 4,000 miles before reaching Earth's iron core. That's already a distance that challenges comprehension. 4,000 miles. You could drive a car for 60 hours straight at highway speeds and still not cover that distance. And yet, on the scale of the cosmos, this journey to the center of the Earth is less than a single step, less than a heartbeat, practically nothing at all. Let's expand our view gently, like a camera slowly pulling back from a close-up shot. Your room sits within a building, your building within a neighborhood, your neighborhood within a city or a countryside that stretches to horizons you might know well. Perhaps you can picture the landscape around you for miles in each direction, the streets you've walked, the hills you've climbed, the familiar territories of your daily life. All of this, every place you've ever been on Earth's surface, exists on the thin skin of our planet, a layer of livable space no more than a few miles thick. Below is solid rock and molten metal. Above is air that quickly becomes too thin to breathe. We live our entire lives in this narrow band, this delicate margin between the solid and the void. Now we rise higher, and the view changes in ways that can make the heart quiet with awe. From a few hundred miles up, where the International Space Station orbits, Earth reveals itself as it truly is, a sphere of blue and white and brown, hanging in absolute darkness. The astronauts who have seen this view often speak of how it changed them, how it made them understand viscerally what we know intellectually, that Earth is a single system, a lonely oasis of life in an ocean of emptiness. From this height you can see the curve of the planet, the thin line of atmosphere that keeps us alive, glowing blue against the black of space. It's beautiful and fragile and complete, like a soap bubble floating in an infinite dark room. But we're just beginning our journey outward, and already the scales are becoming difficult to grasp. The Moon, our nearest celestial neighbour, orbits at an average distance of about 240,000 miles from Earth. That's about 30 Earth diameters away. If Earth were the size of a basketball, the Moon would be a tennis ball about 24 feet away. The space between them would be empty, absolutely empty, just vacuum and darkness and the occasional passing particle. This emptiness, this vast gap between objects, is the rule rather than the exception in our universe. Matter, the stuff we're made of, the stuff that seems so solid and present to us, is actually incredibly rare. The universe is mostly nothing, punctuated by tiny islands of something, separated by distances that mock our intuitions about space and time. When the Apollo astronauts travelled to the Moon, the journey took them about 3 days. 3 days of flying through nothingness at speeds that would cross the continental United States in minutes. 3 days of watching Earth shrink behind them and the Moon grow ahead, with nothing but darkness on every other side. They were the first humans to experience truly cosmic isolation, to know what it feels like to be suspended between worlds with no ground below and no sky above, just the infinite depth of space in every direction. And yet, their journey to the Moon, extraordinary as it was, barely took them into the front yard of our cosmic neighbourhood. The Sun, the star that makes life on Earth possible, sits at an average distance of about 93 million miles from us. This distance, called an astronomical unit, becomes our measuring stick for the solar system. Light itself, the fastest thing in the universe, takes 8 minutes and 20 seconds to travel from the Sun to Earth. When you see the Sun in the sky, or feel its warmth on your skin, you're experiencing the Sun as it was 8 minutes ago. If the Sun were to suddenly disappear, an impossibility but useful for understanding, we wouldn't know for 8 minutes. We'd continue to see its light, feel its heat, orbit around a star that no longer existed until those final photons completed their journey across the void. To help grasp these distances, let's shrink things down again. If the Sun were the size of a bowling ball, Earth would be a peppercorn about 26 yards away. Mars would be a smaller peppercorn about 40 yards from the bowling ball. Jupiter, the giant of our solar system, would be a chestnut about 140 yards away. And Pluto, at the edge of what we traditionally considered our solar system, would be another tiny peppercorn about half a mile from our bowling ball Sun. In this scale model, the nearest star, Proxima Centauri, would be another bowling ball 4,000 miles away. The emptiness between stars is so vast that even our dramatically shrunk model can't make it comprehensible. Our solar system, this collection of planets and moons and asteroids and comets, all held in the Sun's gravitational embrace, extends far beyond Pluto, the Oort cloud, a sphere of icy, objects that marks the true boundary of the Sun's influence, extends perhaps a light year from our star. That's about 6 trillion miles. 6 trillion! If you started counting now, one number per second, it would take you about 190,000 years to count to 6 trillion. And that's just the boundary of our solar system, just the limit of our Sun's gravitational dominion. We haven't even properly left home yet. But let's keep going, because the universe doesn't stop at the edge of our solar system. The nearest stars to our Sun form the Alpha Centauri system about 4.3 light-years away. When we see Alpha Centauri in the night sky, if you're in the southern hemisphere where it's visible, you're seeing light that left those stars 4.3 years ago. You're literally looking back in time, seeing the star as it was when that light began its journey. This is true for everything we see in the universe beyond our solar system. The farther away something is, the further back in time we're seeing it. The universe is a kind of time machine, showing us its own history written in light. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Billion. Each of these stars is a sun, many with their own families of planets, their own possibilities for life, their own stories playing out across cosmic time. If you could visit one star per second, it would take you over 12,000 years to visit them all. And yet, on clear dark nights, when you look up at the Milky Way stretching across the sky like a river of light, you're seeing only a tiny fraction of these stars. Most are too far away, too dim, or hidden behind clouds of interstellar dust. The galaxy is about 100,000 light-years across, a spiral of stars and gas and dust rotating slowly around a supermassive black hole at its centre. When we look at the Milky Way from Earth, we're seeing it edge on from inside one of its spiral arms. We're about 26,000 light-years from the galactic centre, in what astronomers sometimes call the galactic suburbs, not the busy downtown where stars are packed closely together, not the sparse outskirts where stars are rare, but a comfortable middle distance where conditions happen to be just right for a star like our Sun to form, for planets like Earth to coalesce, for life to emerge and evolve and eventually wonder about its place in the cosmic order. The Milky Way itself is moving, travelling through space at about 1.3 million miles per hour relative to the cosmic microwave background radiation, the afterglow of the Big Bang. But moving toward what? And through what? The galaxy is part of a collection of galaxies called the Local Group, about 54 galaxies bound together by gravity, most of them small dwarf galaxies orbiting around the two giants, our Milky Way and the Andromeda Galaxy. Andromeda is about 2.5 million light-years away, the most distant object visible to the naked eye under good conditions. When you see Andromeda, a faint fuzzy patch in the constellation of the same name, you're seeing light that left that galaxy when the earliest human ancestors were just beginning to walk upright on Earth. The Local Group itself is part of a larger structure called the Virgo supercluster, containing thousands of galaxies spread across 110 million light-years of space. And the Virgo supercluster is just one lobe of an even larger structure called Laniakea, a supercluster of superclusters containing 100,000 galaxies, including our own. The name Laniakea comes from Hawaiian, meaning immense heaven, and it's an appropriate name for a structure so vast that light takes 500 million years to cross it. And yet, even Laniakea is just one of many such structures in the observable universe, foam on the surface of an ocean whose depths we can barely imagine. Between these clusters and superclusters are voids, vast regions of space containing almost no galaxies at all. The Bhuta's Void, sometimes called the Great Nothing, is a roughly spherical region of space 330 million light-years in diameter that contains only about 60 galaxies. In a region that size, we would expect to find about 2,000 galaxies. The void is so empty that if the Milky Way were at its centre, we wouldn't have discovered other galaxies until the 1960s. These voids, these vast emptinesses between the filaments of galaxies, make up most of the volume of the universe. Once again, we find that emptiness is the rule, matter the exception, loneliness the default state of existence. The observable universe, the portion of the universe we can see because light has had time to reach us since the Big Bang, extends about 46.5 billion light-years in every direction from Earth. You might wonder how we can see 46.5 billion light-years away when the universe is only 13.8 billion years old. The answer lies in the expansion of space itself. While light has been travelling toward us, space has been expanding, carrying the sources of that light farther away. The most distant galaxies we can see were much closer when their light began its journey toward us. Now they're far beyond where they appeared to be, carried away by the cosmic expansion like boats on an outgoing tide. This observable universe contains an estimated 2 trillion galaxies. 2 trillion. Each galaxy contains hundreds of billions of stars on average. The total number of stars in the observable universe is something like 1024. That's a 1, followed by 24 zeros. There are more stars in the universe than there are grains of sand on all the beaches and deserts of Earth. More stars than there have been seconds since the Big Bang. More stars than there have been heartbeats of all the humans who have ever lived. And around many of these stars orbit planets, worlds beyond counting, each potentially as complex and varied as Earth. When we talk about these numbers, these distances, these scales, our minds don't really comprehend them. We can work with them mathematically. We can create analogies and models, but we can't truly grasp what it means for something to be a billion light years away. Our brains evolved to deal with human scales, distances we can walk, times we can wait, numbers we can count. The universe operates on scales that dwarf our intuitions, that make our everyday experience seem like a single grain of sand on an infinite beach. And yet, here we are, tiny collections of atoms on a small planet, somehow able to measure and map and wonder about it all. The calmness of the cosmos is perhaps its most striking feature when we consider these vast scales. Yes, there are explosions, supernovas that briefly outshine entire galaxies, black holes colliding with violence that sends ripples through space-time itself. But these events are rare, separated by vast distances and long periods of quiet. Most of space is silent, dark, and still. Galaxies rotate so slowly that their movement is imperceptible on human timescales. Stars burn steadily for billions of years. Planets orbit in regular, predictable paths. The universe, for all its size and complexity, is a remarkably peaceful place. This cosmic calm extends through time as well as space. The universe has been expanding and cooling for 13.8 billion years, and it will likely continue to do so for trillions of years to come. Stars will continue to form for perhaps another 100 trillion years. After that, the universe will enter what cosmologists call the degenerate era, when stars no longer shine and only white dwarfs, neutron stars and black holes remain. Even these will eventually evaporate through Hawking radiation, leaving nothing but elementary particles separated by vast and ever-growing distances. The universe, it seems, is patient beyond all human understanding, playing out its story on timescales that make the entire history of Earth seem like a single breath. In this vast, calm cosmos, our imagined edge takes on new meaning. If the universe is as large as our observations suggest, if it contains structures like Laniakea and voids like Boötes, then any edge must be almost impossibly far away. It must lie beyond the observable universe, beyond the cosmic horizon that marks the limit of what we can see. And yet, if the universe is finite, if it has a definite size no matter how large, then edges of some kind must exist. Perhaps not edges in the traditional sense, but boundaries, limits, places where the nature of space itself might change or end. Think about what it means to travel towards such an edge. Even at the speed of light, the journey would take billions of years just to reach the edge of what we can currently see. To go beyond that, to reach a hypothetical edge of the entire universe, might take trillions of years or longer. The universe might expand faster than you could travel, the edge receding forever like a horizon you can never reach. Or perhaps, as some theories suggest, there is no edge in the traditional sense. Space might curve back on itself, or extend infinitely, or have a topology so strange that the very concept of an edge becomes meaningless. But tonight, in our gentle exploration, we're not bound by the speed of light or the expansion of space. In our imagination, we can drift past all these structures, past the local group, past Laniakea, past the most distant galaxies we can see, into the darkness beyond. What would we find there? More galaxies, probably, extending far beyond our cosmic horizon. The universe beyond what we can see is likely much like the universe we can observe. Galaxies and voids, clusters and superclusters, all arranged in the same cosmic web pattern we see around us. But how far does it go? If we could somehow travel instantly to a galaxy at the edge of our observable universe, we would see a different observable universe around us, centered on that galaxy just as our observable universe is centered on Earth. From there, we could see galaxies that are invisible to us, galaxies that lie beyond our cosmic horizon, and from one of those galaxies, we could see even farther, and so on, perhaps forever. Or perhaps, eventually, we would reach a place where the galaxies thin out and stop, where space itself comes to an end, where we would find the edge we've been imagining. The vastness we've been exploring makes our imagined edge seem both more impossible and more necessary. Impossible because the universe is so large that any edge must be unimaginably far away, perhaps so far that the concept of distance itself breaks down. But necessary because our minds rebel against true infinity, because we need boundaries to make sense of things, because even the largest structures we've discovered, superclusters and voids and the cosmic web itself, have edges and limits. Why should the universe as a whole be any different? As you lie there, perhaps feeling very small after contemplating these cosmic scales, remember that you are also part of this vastness. The atoms in your body were forged in the cores of stars that exploded billions of years ago. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of it was created in stellar furnaces and scattered across space in supernovas. You are not separate from the universe. You are a part of it that has temporarily organized itself into a pattern capable of contemplating the whole. In a very real sense, you are the universe thinking about itself, wondering about its own edges. This perspective, seeing ourselves as part of the cosmic story rather than separate from it, changes how we think about the edge of the universe. If we could somehow reach that edge, we wouldn't be arriving as outsiders, as explorers from somewhere else. We would be part of the universe touching its own boundary, like a wave reaching the shore of its own ocean. The hand you imagine extending toward the edge is made of universe, reaching for universe in an act of cosmic self-discovery that might be the whole, point of consciousness existing at all. The calmness of the cosmos, its vast scales and slow processes, can be deeply comforting when we approach it with the right mindset. Yes, we are small, temporary arrangements of matter in an ocean of space and time that dwarfs our existence. But we're also the universe's way of knowing itself, of measuring its own vastness, of wondering about its own nature. Every time you look up at the night sky, every time you contemplate these impossible distances and incomprehensible scales, you're participating in something profound, the universe's ongoing discovery of what it is and what it might be. So as we prepare to explore what an edge might mean in this vast, calm cosmos, carry with you both the sense of scale we've developed and the sense of connection. You're incredibly small in the universe, but you're also part of its grandeur. The edge we're imagining might be 46.5 billion light-years away, or 1 trillion light-years away, or might not exist at all in any conventional sense. But the fact that we can imagine it, that we can use our minds to reach across all those light years and wonder what lies at the boundary of everything, that's a kind of magic that's just as remarkable as the vastness itself. What does it mean to say something has an edge? In our everyday experience, edges are everywhere, so common we barely notice them until we stop to think about what they really are. The edge of a table is where the solid surface stops and air begins. The edge of a forest is where trees give way to open field. The edge of the ocean is where water meets land, though this edge moves with every wave, every tide, reminding us that some boundaries are fluid, temporary, more suggestion than statement. When we talk about the edge of the universe, we're borrowing this familiar concept and trying to apply it to something that might be fundamentally different from anything in our ordinary experience. Let's start with what scientists mean when they talk about edges or boundaries in cosmology, because it's quite different from what our intuition might suggest. When cosmologists speak of the edge of the observable universe, they're not talking about a place where space stops or where you'd hit a wall. They're talking about a horizon, a limit to how far we can see given the finite speed of light and the finite age of the universe. Light from objects beyond this horizon hasn't had time to reach us yet. It's like standing in a fog where you can only see a certain distance in any direction. There's more world beyond what you can see, but the fog creates a practical edge to your observable environment. This observable edge is real in the sense that it represents a genuine boundary to our knowledge. We cannot, even in principle, see beyond it with any telescope using electromagnetic radiation. The cosmic microwave background radiation, that faint afterglow of the Big Bang that fills all of space, represents another kind of edge, the edge of transparency. Before the universe was about 380,000 years old, it was opaque to light, filled with a hot plasma that scattered photons like fog scatters headlight beams. When the universe cooled enough for atoms to form, it suddenly became transparent, and the light from that moment has been travelling toward us ever since. When we detect this ancient light, we're seeing the universe as it was at that moment of transparency, unable to peer any deeper into the past using light. But these are observational edges, horizons created by the limitations of light and time. What about a real, physical edge to space itself? This is where things become strange and wonderful and difficult to imagine. Modern cosmology, based on Einstein's general relativity, and our observations of the universe's large-scale structure, suggests that space might not have edges in any traditional sense. The universe might be infinite, extending forever in all directions without boundary or limit, or it might be finite but unbounded, like the surface of a sphere, where you can travel forever without finding an edge because the space curves back on itself. To understand this possibility, imagine you're a two-dimensional being living on the surface of a sphere, let's say Earth, but pretend you can only move along the surface, never up or down. From your two-dimensional perspective, you could walk forever in any direction without finding an edge. You'd eventually return to where you started, having circumnavigated your spherical world, but you'd never encounter a boundary where the surface stops. The surface is finite. It has a definite area, but it has no edges. Now try to imagine the same thing in 3 dimensions. Our 3-dimensional space might curve in a 4th dimension we can't directly perceive, creating a universe that's finite but has no edges, no boundaries, no place where space stops. This is deeply counterintuitive because every finite thing in our experience has edges. A basketball is finite and has a surface that marks its edge. A room is finite and has walls. Even things that seem edgeless at first, like the surface of Earth, have edges when we consider them in 3 dimensions. Earth's surface is bounded by the atmosphere above and the solid ground below. But the universe as a whole might not follow these rules. It might be finite without having any edges at all, a possibility that challenges our basic assumptions about how space works. Another possibility is that the universe is infinite and has always been infinite, even at the moment of the Big Bang. This seems paradoxical. How can something infinite expand? But remember, the Big Bang wasn't an explosion in space, it was an expansion of space itself. In an infinite universe, the Big Bang happened everywhere at once. Every point in space was once compressed to extreme density and temperature, and every point has been expanding and cooling ever since. In this model, there are no edges, because space simply continues forever. No matter how far you travel, there's always more universe ahead of you, always more galaxies, more stars, more space stretching endlessly into the distance. But tonight, we're allowing ourselves to imagine something different. What if, despite what our theories suggest, the universe does have actual edges? What if there's a place where space itself comes to an end? This isn't scientifically supported, but it's a thought experiment worth pursuing because it helps us understand what edges mean and why the universe probably doesn't have them in any conventional sense. So let's explore what such an edge might be like, using our imagination to probe the boundaries of possibility. One way to think about an edge of the universe is to imagine space gradually thinning out as you approach the boundary. Perhaps the fabric of space-time itself becomes less dense, like air becoming thinner as you climb a mountain. The laws of physics might start to break down or change. Time might flow differently. The constants of nature, the speed of light, the strength of gravity, the masses of elementary particles might shift and fluctuate. Matter might become impossible to form. Even the vacuum of empty space, which in our universe seethes with virtual particles popping in and out of existence, might become truly empty, truly nothing. This kind of edge would be detectable long before you reached it. As you approached, you'd notice strange things happening. Your atoms might start to feel wrong, their electrons orbiting at different energies, their nuclei becoming unstable. The light from distant stars might shift and distort in ways that current physics can't explain. Space itself might feel different, offering more or less resistance to your motion, changing the meaning of distance and direction. This wouldn't be a sharp boundary, but a gradual transition zone, where the familiar universe slowly gives way to something else, or to nothing at all. Another conception of the edge might be more like a membrane, a surface that marks the boundary of our universe. String theory and its extension, M theory, suggest that our universe might be a 3-dimensional brain, floating in a higher dimensional space called the bulk. Other universes, other brains might float nearby in this higher dimensional space, occasionally colliding with ours in events that might trigger big bangs. In this model, the edge of our universe would be the edge of our brain, a boundary that exists in dimensions we can't directly perceive, but that nonetheless marks a real limit to our three-dimensional space. If you could somehow reach such a membrane edge, what would you experience? Perhaps nothing at all. Your three-dimensional existence might simply stop at the boundary, unable to continue into dimensions you don't have access to. Or perhaps you'd feel a resistance, a force preventing you from going further, like trying to push through an invisible wall. Or maybe, most strangely, you'd pass through the membrane and find yourself in another universe entirely, one with different physical laws, different dimensions, different possibilities for matter and energy and life. The edge might also be temporal rather than spatial. Some cosmological models suggest that space and time are so intimately connected that an edge of space would also be an edge of time. As you approach this boundary, time might slow down, stretching each moment longer and longer until, at the edge itself, time stops completely. You'd be frozen at the boundary, unable to move forward because forward requires time, and time has ended. From your perspective, you'd never quite reach the edge. You'd get closer and closer, time stretching more and more, the final approach taking an eternity that never quite completes. Or consider an even stranger possibility. The edge might be probabilistic rather than deterministic. Quantum mechanics tells us that at the smaller scales, reality is fundamentally uncertain, described by probabilities rather than definite states. Perhaps at the edge of the universe, this quantum uncertainty expands to macroscopic scales. Objects might fade in and out of existence. The boundary itself might fluctuate, sometimes extending further, sometimes contracting, like a shore that moves with quantum tides. Touching such an edge would be like trying to grasp a cloud. The closer you look, the less definite it becomes. There's also the possibility that what we call the edge is really just a transition to a different phase of existence. Water has edges where it meets air, but these edges are really just transitions between different states of matter. Perhaps the universe has similar phase transitions, places where the nature of space itself changes from one form to another. Beyond the edge might not be nothingness, but a different kind of somethingness, a phase of existence our physics hasn't discovered yet, where the rules are different, but not absent. Let me paint you a picture of approaching such a phase transition edge. As you travel outward through the cosmos, past the last galaxies, through the great voids, you begin to notice subtle changes. The darkness between stars seems different somehow, not just empty but expectant. Space itself feels thinner, more flexible, as if the rigid structure that holds our universe together is beginning to loosen. You're entering a region where our familiar physics is giving way to something else, where the universe is preparing to transform into a different state of being. The stars behind you, if any were still visible at this incredible distance, would look strange, their light stretched and distorted not just by distance and cosmic expansion, but by the changing nature of space itself. Ahead, you might see hints of the other phase, glimpses of a reality that operates on different principles. Perhaps space there has more dimensions or fewer. Perhaps matter and energy are unified in ways we can't achieve in our phase. Perhaps consciousness and physics are connected differently, more intimately, so that thought and reality are harder to distinguish. This kind of edge wouldn't be a barrier so much as a graduation, a place where the universe evolves from one state to another. Crossing it might transform you as well, changing your fundamental nature to match the new phase of existence. You wouldn't be destroyed or stopped. You'd be translated like a word being spoken in a different language, maintaining meaning while changing form. But let's return to the most profound question about edges. What would be on the other side? If the universe has an edge, there must be something beyond it, right? Our minds insist on this. Every edge we know has two sides. Every boundary separates two regions. But this might be a failure of imagination, a limitation of minds that evolved in a world where edges always have another side. The edge of the universe might be an edge in a more absolute sense than anything we've experienced, a boundary beyond which there simply isn't anything. Not empty space, not darkness, not even nothingness in any sense we can conceive. This absolute edge would be philosophically troubling. How can space just stop? What prevents us from going further? These questions might be meaningless, like asking what's north of the North Pole or what happened before time began. The edge might represent a limit not just of space but of existence itself, a boundary beyond which the very concepts of space, time, matter, energy and existence have no meaning. It would be like reaching the edge of a dream and finding not another dream or waking reality but the absence of experience itself. Yet even this absolute edge could be touched in our imagination. The act of touching would be the universe discovering its own limit, consciousness meeting the boundary of what can be. Your hand, made of atoms forged in stars, organized by billions of years of evolution, reaching out to touch the place where being meets non-being. It's a poetic image that captures something essential about the human desire to explore, to understand, to push against every limit we encounter. The scientific consensus, based on our best observations and theories, is that the universe probably doesn't have edges in any of these senses. The observable universe has a horizon, but there's almost certainly more universe beyond it. The whole universe might be infinite, or it might be finite but unbounded, curving back on itself in ways we can barely imagine. But the absence of edges doesn't make the universe less mysterious or wonderful. If anything, it makes it more so. A universe without edges is a universe where exploration never has to end, where there's always more to discover, where the journey can continue forever without running into a wall that says stop. And yet the human imagination needs edges, craves boundaries, seeks limits to push against. We define ourselves by our edges, the boundary of our skin, the limits of our lifespan, the extent of our knowledge. Perhaps this is why we keep returning to the idea of a universal edge, why we can't quite let go of the notion that somewhere, somehow, the universe must come to an end. It's not a scientific belief but a psychological need, a desire for closure, for completeness, for a universe we can hold in our minds even if we can't hold it in our hands. As we continue our journey through this cosmic meditation, remember that the edge we're imagining serves a purpose beyond scientific speculation. It's a tool for thinking about limits and infinities, boundaries and boundlessness, the known and the unknowable. Whether or not the universe has actual edges, the idea of edges helps us explore what it means to exist in a cosmos that might be infinite, might be finite, might be stranger than either option suggests. The edge of the universe, real or imagined, is ultimately a mirror that reflects our own limitations and possibilities. When we imagine touching it, we're really exploring the edges of human understanding, the boundaries of consciousness, the limits of what minds like ours can comprehend. And perhaps that's the most important edge of all, not the edge of space or time, but the edge of awareness, the boundary between what we know and what we can imagine, the horizon that expands every time we dare to wonder what lies beyond. So as you drift towards sleep, carried by these thoughts of edges and boundaries, remember that you carry edges within you as well, the edge between waking and sleeping, between conscious and unconscious, between self and universe. These edges are just as mysterious as any cosmic boundary, just as worthy of exploration. And unlike the edge of the universe, which might not exist or might be unreachably far away, these internal edges are always with you, always available for exploration, always ready to teach you something about the nature of limits and the limitless imagination that contemplates them. The question, what is an edge of the universe really, doesn't have a simple answer. It might not have any answer at all, but the questioning itself, the wondering, the imagining, that's where the magic lives. In our uncertainty, in our curiosity, in our willingness to think about things that might be impossible, we touch something essential about what it means to be conscious beings in a universe that might or might not have boundaries. And that touch, that contact between mind and mystery, might be the closest we ever come to touching the edge of everything. And so we begin our journey outward, not with rocket engines or warp drives, but with the gentle propulsion of imagination, that uniquely human ability to travel beyond the boundaries of the possible. Close your eyes for a moment, if you haven't already, and picture yourself rising slowly from where you lie, passing through your ceiling as if it were nothing more than a suggestion, through the roof, into the night air above. You're weightless now, unbound by gravity, free to drift in any direction you choose. The earth falls away beneath you, not dramatically, but gently, like watching a balloon released by a child, growing smaller as it rises into the blue. This is no ordinary journey we're embarking upon. We're not constrained by the laws of physics that bind spacecraft and light itself. In our vessel of thought, we can move at the speed of imagination, crossing distances that light would take billions of years to traverse in mere moments of contemplation. Yet we choose to travel slowly at first, savouring each stage of our outward voyage, because the journey toward the edge is just as important as the destination, perhaps more so. Each milestone we pass teaches us something about scale, about emptiness, about the profound quietness that defines most of the universe. Below you now, Earth has become a sphere, that famous blue marble photographed by astronauts, but seen now with your own imagined eyes. The continents are visible through breaks in the clouds, Africa's familiar shape, the sprawl of Asia, the Americas waiting for sunrise or settling into sunset, depending on when you began this journey. The thin film of atmosphere that keeps us all alive glows like a soap bubble around the planet, so delicate you could almost reach down and pop it with a finger. But we're moving away from it now, that precious envelope of air becoming thinner, fainter, until it's just a suggestion of blue against the black. The moon slides into view, or perhaps you pass it, depending on where it sits in its monthly orbit around Earth. Up close, it's not the smooth, silvery disk we see from Earth's surface, but a battered world, covered in craters and ancient lava flows, mountains and valleys that have stood unchanged for billions of years. There's something profoundly lonely about the moon, this airless companion that has watched Earth transform from a molten ball to a living world that has witnessed the entire history of life without participating in any of it. We pause here for a moment, floating above the sea of tranquility, where humans first walked on another world, leaving footprints that will last for millions of years in the absence of wind or rain to erase them. But we can't linger. Our destination is infinitely farther than the moon, incomparably more distant than any place humans have ever been. We accelerate gently, watching the moon shrink behind us until it's just another point of light, distinguishable from the stars only because we remember what it looked like up close. Earth and moon become a double star, then a single point as the distance grows, until even that point fades into the general starlight, lost among the countless other points of light that fill the darkness. We're truly in space now, the space between worlds, where the solar wind blows invisibly past us carrying charged particles from the sun out toward the edge of its influence. In our imagined vessel, we can feel this wind if we choose to, a gentle pressure like the faintest breath against our consciousness. We pass the orbit of Mars, though the red planet itself is elsewhere in its journey around the sun. We could visit it, see its rusty deserts and its polar caps of frozen carbon dioxide, its enormous volcanoes and vast canyons, but that's not our purpose tonight. We're headed outward, always outward, toward the boundary we've been imagining. The asteroid belt comes next, though it's nothing like the dense field of rocks you might picture from science fiction movies. The asteroids are scattered so widely that you could fly through the belt 1,000 times and never come close to one. They're lonely mountains tumbling through the darkness, remnants of a planet that never quite formed, or perhaps fragments of one that was destroyed. Some are just pebbles, others are hundreds of miles across. Ceres, the largest, is a dwarf planet in its own right, a world of rock and ice that might harbour an ocean beneath its surface. But we pass through without stopping, the asteroids invisible in the darkness unless they happen to catch the distant sunlight just right. Jupiter looms ahead, growing from a star to a disk to a vast banded sphere that fills our view. Even in our imagination, Jupiter is intimidating, a giant that could swallow Earth 1,000 times over. Its great red spot, a storm larger than our entire planet, swirls with winds that would shred any earthly material. Jupiter's radiation would kill an unprotected human in minutes, its gravity so strong that it bends the paths of comets and asteroids, protecting the inner solar system from many potential impacts. We might pause to observe its moons, Io with its sulfur volcanoes, Europa with its hidden ocean, Ganymede larger than Mercury, Callisto battered by billions of years of impacts. But we're drawn onward, outward, toward the edge. Saturn arrives like a piece of cosmic jewellery, its rings catching the sunlight in ways that seem almost deliberately beautiful. The rings are made of countless pieces of ice, from tiny crystals to house-sized chunks, all orbiting in a flat disk so thin that when edge on, they practically disappear. Saturn itself is less dense than water. If you could find an ocean large enough, the planet would float. Its moon, a Titan, larger than Mercury and shrouded in a thick atmosphere, has lakes and rivers of liquid methane, a bizarre mirror of Earth's water cycle in the frozen outer solar system. Enceladus shoots geysers of water into space from its subsurface ocean, creating one of Saturn's rings in the process. These are worlds that might harbour life, but we can't stop to investigate. The edge calls us onward. Beyond Saturn, the solar system becomes a lonelier place. Uranus rotates on its side, knocked over by some ancient collision, its faint rings vertical rather than horizontal. Neptune, deep blue and storm-tossed, marks the traditional boundary of the planetary solar system. But we keep going, out into the Kuiper belt where Pluto orbits with its oversized moon Charon, where thousands of other icy worlds circle the distant sun. The sun itself has shrunk to just the brightest star in the sky, its warmth negligible, its light barely enough to distinguish day from night on these frozen worlds. Further still, we enter the scattered disk, then the beginning of the Oort cloud, that vast sphere of comets that extends perhaps a light year from the sun. Here, in the deep freeze of the outer solar system, millions or billions of chunks of ice and rock orbit so slowly that a single circuit around the sun might take millions of years. Occasionally one of these chunks gets nudged inward, beginning a long fall toward the sun that will transform it into a comet, growing a tail of vapour that might be visible from Earth. But most remain here forever, in the darkness between the stars, the furthest outposts of our sun's gravitational empire. And now, finally, we're leaving the solar system truly behind. The sun's gravity still tugs at us, will continue to tug for a long time yet, but it's weak now, barely distinguishable from the gravitational pulls of other stars. We're entering interstellar space, the void between stars, where the darkness is more complete than anything you can experience on Earth. Here, the temperature is only a few degrees above absolute zero. The particles of matter are so sparse that a volume the size of Earth might contain only a few atoms. This is the emptiness that makes up most of the galaxy, most of the universe, not the dramatic spaces of stars and planets and nebulae, but the quiet void between them. In our imagined journey, we can cross this void in moments or hours, whatever feels right for your descent towards sleep. But let's appreciate its vastness for a moment. The Voyager spacecraft, humanity's first interstellar travellers, will take 40,000 years to come within 2 light years of another star. At the speed of light itself, it would take 4.3 years to reach Proxima Centauri, our nearest stellar neighbour. The void between stars is so vast that if the sun were a grain of sand in New York, Proxima Centauri would be another grain of sand in Los Angeles, with nothing but emptiness between them. But we're not bound by such limitations. We accelerate through the interstellar darkness, watching the stars begin to shift position as we travel distances that light takes years to cross. Behind us, the sun fades from the brightest star to just another point of light, then becomes lost among the thousands of other stars visible to our imagined eyes. Ahead, new stars become visible, stars that are invisible from Earth because their light is too faint or blocked by interstellar dust. We're seeing the galaxy from a new perspective, a viewpoint no human has ever had. We pass other solar systems now, though we don't stop to explore them. Some have planets we can glimpse, hot Jupiters orbiting close to their stars, super-Earths that might be rocky or might be mini-Neptunes, systems with multiple stars where planets, if they exist, would have skies with 2 or 3 suns. Each system is a story unto itself. Billions of years of history we'll never know, possibilities for life and intelligence we can only guess at. But we're drawn onward, outward, toward the edge that might or might not exist. The stars begin to thin as we approach the edge of the Milky Way's disk. We're rising above or below the galactic plane now. Direction becomes somewhat arbitrary when there's no up or down. Looking back, we can see the galaxy spread out like a vast whirlpool of light, its spiral arms traced by bright blue stars and pink nebulae where new stars are being born. The galactic centre glows with the light of millions of stars packed closely together, orbiting around the supermassive black hole that anchors the entire system. It's beautiful beyond words, this island of light in the cosmic darkness, this collection of hundreds of billions of stars that we call home. But we keep going, out into the galactic halo where ancient globular clusters orbit, spherical collections of hundreds of thousands of stars that formed when the galaxy was young. These clusters are like fossils, preserving the conditions of the early universe, stars that have been shining for over 13 billion years. Some of them might be older than the galaxy itself, captured from smaller galaxies that the Milky Way absorbed in its youth. They're scattered through a roughly spherical region around the galaxy, lonely outposts of light in the darkness. And then, gradually, even these fade behind us. We're entering the true intergalactic void now, the space between galaxies where matter is at its rarest. Here there might be only one atom per cubic meter of space, a loneliness so profound it defies comprehension. The darkness is absolute, except for the faint light of distant galaxies, points and smudges of light scattered across the void like islands in an infinite ocean. This is most of the universe, not the galaxies themselves, but the spaces between them, vast and empty and silent. We could travel for millions of light years through this emptiness without encountering anything larger than a stray atom. But in our imagination we can cross it more quickly, watching galaxies approach and pass like ships in the night. Each galaxy is an entire world of stars, an island universe with its own history, its own possibilities. Spiral galaxies like our own, their arms winding through space. Elliptical galaxies, massive spheres of old red stars. Irregular galaxies, twisted by gravitational interactions or collisions. Dwarf galaxies, containing only a few million stars. Giant galaxies with trillions of stars, so massive they bend space around them, creating gravitational lenses that distort the light of more distant objects. We pass through galaxy clusters, regions where hundreds or thousands of galaxies are bound together by gravity, moving through space as a unit. The space between galaxies in a cluster is filled with hot gas, millions of degrees, but so thin it would feel cold to the touch if you could somehow touch it. Dark matter, invisible and mysterious, makes up most of the mass of these clusters, its gravity holding them together against the expansion of the universe. We can't see the dark matter, but we can see its effects. The way it bends light, the way it shapes the distribution of galaxies. Between the clusters are the voids we talked about earlier, regions hundreds of millions of light years across that contain almost no galaxies at all. We enter one of these voids now, and the loneliness becomes even more profound. In every direction, emptiness stretches for distances that light takes hundreds of millions of years to cross. The few galaxies that exist in voids are isolated beyond imagining, island universes in the truest sense, separated from their nearest neighbours by gulfs that dwarf the distance between stars. If intelligent life exists in a void galaxy, they might never discover that other galaxies exist at all. But we press on because we're not looking for galaxies now. We're looking for the edge, the boundary, the place where it all stops. According to our current understanding, we could travel forever and never find such a place. The universe might be infinite, or it might curve back on itself, or it might simply extend far beyond what we can see or imagine. But tonight, in our gentle meditation, we allow ourselves to believe that somewhere ahead, unimaginably far but still finite, still reachable in the realm of thought, there is an edge waiting for us. The galaxies have become sparse now, in our imagination. We're approaching the edge of the observable universe, that sphere centered on Earth beyond which light hasn't had time to reach us since the Big Bang. But we keep going, past this observational boundary, into regions no telescope will ever show us. What lies beyond? More galaxies probably, extending perhaps infinitely into the distance. But in our thought experiment, we imagine them thinning out, becoming rarer, until finally we see the last galaxy, a lonely island of light in an ocean of darkness that has no other shore. We approach this last galaxy slowly, reverently. It's an elliptical galaxy, old and red, its star formation long since ended. The stars it contains will shine for trillions of years more, but no new stars will be born. It's a galaxy in retirement, slowly fading, a last outpost of light before the final darkness. We pass through it, seeing stars for the last time, each one a sun that might warm planets we'll never know about, might nurture life we'll never meet. And then we're through, out the other side, and ahead of us is only darkness. But not the darkness we've known so far. This is different. The darkness between stars and between galaxies was an absence of light, but it was still space, still part of the universe. The darkness ahead feels different. It's not just an absence of light, but an absence of space itself, an absence of the possibility of light. We're approaching the edge we've been imagining, the boundary of everything, and we can feel it even though feeling is the wrong word for this sensation that has no analogue in human experience. We slow our approach, savouring this moment. Behind us, unimaginably far away, is everything that exists. Every galaxy, every star, every planet, every atom, every thought and dream and memory. Earth is back there somewhere, so distant that light leaving it now wouldn't reach us for trillions of years if we waited. Everyone you've ever known, everyone who has ever lived, exists in that direction, in that sphere of space and time we're about to leave behind. And ahead is the edge, the boundary, the limit of existence itself. What does it look like, this edge we've imagined our way to? In the darkness, it's hard to see at first, but gradually we become aware of a presence, a surface, a something that distinguishes itself from the nothing around it. It might shimmer faintly with some kind of energy we don't have a name for. It might be perfectly black, but somehow visible against the darkness, the way you can see a black hole's event horizon by the way it occults the stars behind it. Or it might be transparent, visible only by the way space itself changes as we approach it, distances becoming uncertain, directions losing their meaning. We're very close now, close enough to reach out if we had hands to reach with. The edge fills our perception, not violent or threatening, but patient, eternal, waiting. It has always been here, will always be here, the ultimate boundary that defines the universe by being what the universe is not. We float before it, tiny conscious specks at the limit of everything, and we prepare to do what we came here to do. We prepare to touch the edge of existence itself. But not yet. The moment stretches, prolonging itself, because once we touch the edge, our journey will be complete in a sense, though of course it can never really be complete. The edge, if it exists, isn't a destination but a mirror, showing us ourselves and our universe from the ultimate outside perspective. As we float here, hand extended but not yet making contact, we exist in a state of pure potential, at the boundary between the known and unknowable, between something and nothing, between the universe and whatever lies beyond. While we float here at the imagined edge, hand extended toward that ultimate boundary, let's turn our attention back toward the universe we've travelled through, because it carries within itself clues about its own nature, whispers about whether edges exist and what form they might take. The universe, you see, has been sending us messages since the beginning of time, encoded in light and gravity, in the distribution of galaxies and the vibration of space itself. We've only recently learned how to read these messages, how to decode the signals that have been travelling toward us for billions of years, carrying information about the shape and size and fate of everything that exists. The most ancient light we can see comes from a moment 380,000 years after the Big Bang, when the universe transformed from opaque to transparent. Before this moment, the universe was so hot and dense that atoms couldn't form. Electrons were stripped from nuclei, creating a plasma that scattered light like fog scatters headlight beams. But as the universe expanded and cooled, it reached a temperature where electrons could finally settle into orbit around nuclei, forming the first atoms, mostly hydrogen with a little helium. Suddenly, light could travel freely through space, and the universe became transparent. That first free light has been travelling ever since, stretched by the expansion of space from visible light to microwave radiation, creating what we call the cosmic microwave background, or CMB. This ancient light fills the entire universe, coming from every direction, a faint glow that tells us what the universe was like when it was only 380,000 years old, a baby by cosmic standards. When we first discovered this radiation in 1964, it seemed perfectly uniform, the same temperature in every direction to within the precision of our instruments. This uniformity was puzzling. How could regions of space that had never been in contact with each other, separated by distances greater than light, could have travelled since the Big Bang all have exactly the same temperature? It was like finding that everyone on Earth had independently decided to wear the same outfit on the same day, without any communication between them. But as our instruments became more sensitive, we discovered that the CMB isn't perfectly uniform after all. There are tiny variations, differences in temperature of only about 1 part in 100,000. But these tiny differences are the seeds of everything we see in the universe today. Regions that were slightly denser than average had slightly stronger gravity, pulling in more matter, eventually collapsing to form the first stars and galaxies. Regions that were slightly less dense became the voids, the empty spaces between galaxy clusters. The pattern of these variations, mapped across the entire sky, contains information about the universe's geometry, composition, and history. In 1989, NASA launched the Cosmic Background Explorer, or COBE, the first satellite designed specifically to study the CMB in detail. COBE was like a baby picture of the universe, showing us for the first time the tiny fluctuations that would grow into the cosmic structures we see today. The satellite orbited Earth, slowly scanning the entire sky, building up a map of the ancient light with unprecedented precision. When the results were announced showing those first delicate variations in the CMB, cosmologist George Smoot said it was like looking at God. It was our first glimpse of the universe's deepest structure, the fundamental pattern that underlies everything that exists. COBE's success led to even more sophisticated missions. The Wilkinson Microwave Anisotropy Probe, or WMAP, launched in 2001, could see details in the CMB that COBE couldn't resolve. WMAP spent 9 years at a special point in space called L2, where Earth's and Sun's gravity balance in such a way that the spacecraft could maintain a stable position while always keeping its back to the Sun, protecting its sensitive instruments from solar radiation. WMAP's maps of the CMB were so detailed that cosmologists could use them to determine the age of the universe, 13.7 billion years, its composition, about 5% ordinary matter, 27% dark matter and 68% dark energy, and its geometry, flat to within 0.4% margin of error. Then came Planck, a European Space Agency mission launched in 2009, with instruments so sensitive they could detect temperature variations of a few millionths of a degree. Planck's map of the CMB is the most detailed we have, showing features that help us understand not just what the universe is like now, but what happened in the first fraction of a second after the Big Bang. The patterns in this ancient light are like fingerprints, unique signatures that can tell us whether the universe is finite or infinite, whether it has positive curvature like a sphere, negative curvature like a saddle, or is flat like an infinite plane. What do these patterns tell us about edges? The answer is both disappointing and fascinating. The CMB suggests that the universe is very nearly flat, which in the simplest models means it's infinite and has no edges. If you travel in any direction forever, you'll never reach a boundary, never find a place where space stops. The universe goes on forever, containing infinite galaxies, infinite stars, infinite possibilities. This is vertigo-inducing to contemplate, not just a very large universe, but an actually infinite one, where everything that can happen does happen somewhere, an infinite number of times. But very nearly flat isn't the same as exactly flat. The measurements have error bars, uncertainties. The universe could have a very slight positive curvature, so slight we can't detect it yet, which would mean it's finite but unbounded, like the surface of a sphere but in 3 dimensions. In such a universe, if you travelled far enough in a straight line, you'd eventually return to where you started, having circumnavigated the cosmos. The universe would have a finite volume but no edges, no boundaries, no place where space stops. There's another possibility hidden in the CMB data, one that's even stranger. Some cosmologists have noticed unusual patterns in the CMB, alignments and asymmetries that shouldn't exist if the universe is truly infinite and uniform on large scales. There's something called the axis of evil, a terrible name for a fascinating phenomenon, where certain features of the CMB seem to be aligned with the plane of our solar system. This shouldn't happen. The CMB comes from billions of years before our solar system existed. It's probably a coincidence, a statistical fluke, but some scientists wonder if it might be telling us something profound about the universe's structure. One interpretation is that the universe might be smaller than we think, small enough that light has had time to travel all the way around it, perhaps multiple times. In this scenario, some of the distant galaxies we see might actually be images of nearby galaxies, seen from the other side after their light has circumnavigated the universe. We could be living in a hall of mirrors, seeing the same galaxies over and over from different angles, mistaking repetition for vastness. If this is true, the universe might be much smaller than the observable universe, perhaps only a few billion light years across, with edges that are connected to each other in ways we're only beginning to understand. The CMB also contains hints about what happened before it was created, in those first 380,000 years when the universe was opaque. The patterns we see support the theory of cosmic inflation, a period in the first fraction of a second after the Big Bang when the universe expanded faster than the speed of light. This isn't a violation of relativity. Space itself can expand faster than light, carrying matter along for the ride. Inflation would have taken any initial curvature or irregularity and stretched it flat, which explains why the universe appears so uniform on large scales. It would also have pushed any edges far beyond our observable horizon, which is why we don't see them even if they exist. But inflation raises its own questions about edges. If our universe underwent inflation, expanding by a factor of at least 1026 in a tiny fraction of a second, then what we call the universe might be just a tiny pocket in a much larger multiverse. Other regions might have undergone different amounts of inflation, or no inflation at all. There might be bubble universes, each with its own physical laws, its own constants of nature, separated by regions where inflation never stopped. The edges of our universe in this picture would be the boundaries between our bubble and others, or between our bubble and the eternally inflating space between bubbles. Beyond the CMB, we have other cosmic messengers that might tell us about edges. Gravitational waves, ripples in space-time itself, were first detected directly in 2015, though their existence had been inferred for decades. These waves carry information about the most violent events in the universe, colliding black holes, merging neutron stars, perhaps even the Big Bang itself. As our gravitational wave detectors become more sensitive, they might detect signatures of cosmic edges, places where space-time itself behaves differently, where waves reflect or refract in ways that reveal boundaries we can't see with light. We also study the large-scale structure of the universe, the cosmic web of galaxies and voids that extends as far as we can see. Surveys like the Sloan Digital Sky Survey have mapped millions of galaxies, revealing patterns that extend across billions of light years. These patterns show us how matter has clumped together over cosmic time, pulled by gravity into the structures we see today. If the universe has edges, they might affect these patterns, creating asymmetries or boundaries in the distribution of galaxies. So far, we haven't seen clear evidence of such effects, but we've only mapped a tiny fraction of the observable universe in detail. Dark energy, the mysterious force that's causing the universe's expansion to accelerate, might also hold clues about edges. We don't know what dark energy is. It might be a property of space itself, a constant energy density that doesn't dilute as space expands. Or it might be a field that varies through space and time, possibly changing its behavior near cosmic boundaries. The acceleration of expansion means that distant galaxies are moving away from us faster and faster, and eventually they'll be moving away faster than light. When that happens, they'll cross a horizon beyond which we can never see them again, creating a kind of edge, not an edge of space, but an edge of observability, a boundary beyond which the universe becomes forever unknowable. The Hubble Space Telescope, floating above Earth's atmosphere, has been our eye on the deep universe for over 30 years. It has shown us galaxies as they were when the universe was young, only a few 100 million years after the Big Bang. These early galaxies look different from modern ones, smaller, more irregular, often in the process of merging with others. By looking at galaxies at different distances, and therefore different times in cosmic history, Hubble has helped us understand how the universe has evolved. If there are edges, they might affect this evolution, creating patterns in how galaxies form and change over time. The James Webb Space Telescope, Hubble's successor, can see even further into the past, detecting infrared light from the very first stars and galaxies. Its images are already revolutionizing our understanding of the early universe, showing us that galaxies formed earlier and faster than we expected. Some of the galaxies JWST has found seem too massive for their age, challenging our models of cosmic evolution. Could this be a hint that the universe is structured differently than we thought? Could edges or boundaries play a role in these unexpected observations? We also look for edges in the cosmic neutrino background, a sea of neutrinos that fills the universe, created just 1 second after the Big Bang. These ghostly particles barely interact with matter, passing through entire planets as if they weren't there. But they carry information about the universe when it was only 1 second old, much earlier than the CMB. If we could detect and map the cosmic neutrino background, It might tell us about edges that formed in the very early universe, boundaries that predate the patterns we see in the CMB. There's also the possibility of cosmic strings, theoretical defects in space-time that might have formed during phase transitions in the early universe, like cracks that form when water freezes into ice. These strings, if they exist, would be incredibly thin, thinner than an atomic nucleus, but could stretch across the entire observable universe. They would be edges of a sort, one-dimensional boundaries where the structure of space itself changes. We haven't detected cosmic strings yet, but they would create distinctive signatures in the CMB and in the timing of pulsars, which we are actively searching for. All of these observations, all of these cosmic messengers are pieces of a vast puzzle. Each one tells us something about the universe's structure, history, and possible boundaries. The picture that emerges is complex and sometimes contradictory. The universe seems infinite and edgeless in some ways, finite and bounded in others. It might have edges we can't see, or edges that exist in dimensions we can't perceive, or edges that are so far away that light from them will never reach us. What's remarkable is that we can even ask these questions, that beings on a small planet orbiting an ordinary star can gather light that's been travelling for billions of years and use it to map the structure of the cosmos. Every photon of the CMB that enters our detectors has been travelling since the universe was young, carrying its message across time and space just to tell us about the conditions of its birth. Every gravitational wave that ripples through our detectors is a whisper from cosmic catastrophes, black holes colliding in distant galaxies, perhaps even echoes of the Big Bang itself. As our instruments become more sensitive, as our surveys become more complete, we might find clearer evidence for or against cosmic edges. Perhaps we'll discover patterns in the CMB that can only be explained by a finite universe. Perhaps we'll detect gravitational waves that have bounced off cosmic boundaries. Perhaps we'll find that distant galaxies are arranged in ways that reveal the universe's true shape. Or perhaps we'll discover that the universe is truly infinite, truly edgeless, extending forever in all directions without boundary or limit. But even if we never find edges, the search itself teaches us something profound. It shows us that the universe is knowable, that its deepest structures can be revealed by patient observation and careful thought. It shows us that we're part of something vast and beautiful, a cosmos that generates creatures capable of contemplating the cosmos itself. And it reminds us that there are still mysteries to solve, still questions to ask, still wonders to discover. The data whispers to us across the cosmic dark, ancient light, carrying messages we're only beginning to decode. Whether those messages will eventually tell us about edges or confirm their absence, we don't yet know. But we keep listening, keep watching, keep gathering the faint signals from the depths of space and time, because somewhere in those whispers might be the answer to our question. Does the universe have edges we could touch? And even if the answer is no, the fact that we can ask the question, that we can search for edges at the very limits of existence, makes us explorers of the infinite, touchers of boundaries, whether those boundaries exist in space or only in the reaching of our imagination. The universe might not be shaped the way your intuition suggests. When you imagine space, you probably picture something like an enormous box extending in all directions, or perhaps a sphere with Earth at the centre, stretching outward to some distant boundary. These are natural ways to think about space because they match our everyday experience of rooms and horizons. But the universe doesn't have to follow the rules of our everyday experience. It can be twisted, folded, connected in ways that would seem impossible if we didn't have the mathematics to describe them. Tonight, let's explore these stranger possibilities, these exotic shapes that might define the cosmos we inhabit. Consider for a moment the surface of Earth. To someone who has never travelled far, the world seems flat, extending outward with edges somewhere beyond the horizon. But we know Earth's surface is actually curved, wrapping around on itself to form a sphere. If you travel far enough in any direction, you'll eventually return to where you started. The surface is finite. It has a definite area, but it has no edges. You can't fall off the edge of Earth because there is no edge to fall off. Now imagine the same principle applied to three-dimensional space itself. What if our universe curves back on itself in a higher dimension we can't directly perceive? This is more than just an analogy. According to Einstein's general relativity, space can curve, and the way it curves depends on the matter and energy it contains. On small scales, we see this curvature around massive objects. Light bends as it passes the sun. Time slows near black holes. But what about the universe as a whole? Does all of space curve in some consistent way? The answer depends on the total density of matter and energy in the universe. If the density is just right, what cosmologists call the critical density, then space is flat on large scales. If it's higher, space curves positively like a sphere. If it's lower, space curves negatively like a saddle. Our observations suggest the universe is very close to flat, but this doesn't mean it's shaped like an infinite plane. Even flat space can have interesting topologies, interesting ways of connecting to itself. Imagine a video game where walking off the right edge of the screen makes you appear on the left edge, and walking off the top makes you appear at the bottom. The game world is flat. There's no curvature, but it's connected in a way that eliminates edges. Mathematicians call this a torus topology, and our universe could be shaped this way in 3 dimensions. In a toroidal universe, if you travelled far enough in any direction, you'd eventually return to where you started, like Pac-Man emerging from the opposite side of the screen. The universe would be finite but edgeless, repeating itself in all directions. If you could see far enough, you might see the back of your own head, the light having travelled all the way around the universe. Every galaxy would have an infinite number of copies, each one seen from a different angle, as light takes different paths around the cosmic torus. We could be living in a hall of mirrors on the grandest possible scale, but a torus is just the beginning. Mathematicians have catalogued 18 different possible shapes for a flat, finite universe. There's the Klein bottle, a shape that's like a torus but with a twist, literally. In a Klein bottle universe, travelling in certain directions would bring you back to where you started, but mirror reversed. Your heart would be on the right side, your writing would be backward, every atom in your body would be flipped. It's a shape that can only exist properly in 4 dimensions, but our 3-dimensional universe could still have this topology, this strange way of connecting to itself. Then there are the more exotic possibilities. The universe might be shaped like a Poincare dodecahedral space, a kind of cosmic soccer ball where space is tiled by regular dodecahedra, 12-sided shapes that connect to each other in complex ways. In such a universe, there would be exactly 120 copies of everything, each viewed from a different angle. Some cosmologists have looked for evidence of this in the CMB, searching for matching circles that would indicate we're seeing the same regions of space from different directions. They've found some intriguing candidates, though nothing conclusive yet. Or consider the possibility that our universe is just one of many bubbles floating in a higher dimensional space. This idea comes from string theory and its extension, M theory, which suggests that what we call the universe might be a 3-dimensional brain, short for membrane, embedded in a higher dimensional bulk. Other brains, other universes, might float nearby in this higher dimensional space, occasionally colliding with ours in events that could trigger big bangs or leave subtle signatures in the CMB. In the bubble universe scenario, edges take on a different meaning. The edge of our bubble would be a real boundary, a place where our 3-dimensional space ends. But this edge might not be accessible to us, existing as it does in dimensions we can't perceive or travel through. It would be like flatlanders living on a soap bubble, unable to perceive the 3rd dimension that defines their bubble's boundary. We might be similarly limited, aware that our universe could have edges but unable to reach them because they exist in dimensions beyond our 3. These bubble universes might collide occasionally, and some cosmologists think they found evidence of such collisions in the CMB. There are a few spots where the temperature patterns look like what you'd expect if another bubble universe had bumped into ours in the distant past, sending ripples through our cosmic bubble like waves on a pond. If these interpretations are correct, then we've already touched another universe, or rather it has touched us, leaving its fingerprint in the ancient light that fills our sky. The shape of the universe might also change over time. During cosmic inflation, that period of exponential expansion in the first fraction of a second after the Big Bang, any initial curvature or complex topology would have been stretched nearly flat. But nearly isn't completely. As the universe continues to evolve, as dark energy drives accelerating expansion, the shape might become more apparent. Edges that are hidden beyond our current horizon might eventually become visible, or the universe might develop new boundaries as different regions lose causal contact with each other. There's also the fascinating possibility of fractal structure. Fractals are shapes that look similar at every scale. Zoom in on a coastline, and you see smaller bays and peninsulas that resemble the larger coastline. Some cosmologists wonder if the universe might be fractal, with structure repeating at every scale from galaxy clusters down to subatomic particles. In a fractal universe, the concept of edges becomes even stranger. Every boundary would reveal more boundaries when you look closer, edges within edges extending down to infinitesimal scales. Imagine approaching what seems to be the edge of such a fractal universe. As you get closer, you see that what looked like a smooth boundary is actually incredibly complex, full of tendrils and voids and smaller edges. You zoom in on one section, and it reveals the same complexity at a smaller scale. No matter how close you look, there's always more detail, always more structure. The edge exists but can never quite be reached because there's always a smaller edge to explore first. It's like Zeno's paradox made real. You can get arbitrarily close to the edge but never quite touch it because touching requires reaching a finer scale that doesn't exist. Another strange possibility is that the universe has different dimensions in different places. We experience 3 dimensions of space, but string theory suggests there might be more dimensions, curled up so small we can't detect them. What if these extra dimensions aren't the same size everywhere? There might be regions of space where extra dimensions have unfurled, creating pockets of 4 or 5 or 10-dimensional space. The boundaries between regions of different dimensionality would be edges of a sort, places where the very nature of space changes. Crossing such a dimensional boundary would be unlike anything in human experience. Imagine approaching a region where space has 4 dimensions instead of 3. As you get closer, you might start to feel strange new directions becoming available, ways to move that didn't exist before. Objects might appear to change shape as the extra dimension becomes visible. A sphere might reveal itself to be the 3-dimensional shadow of a 4-dimensional hypersphere. You might be able to step sideways in a direction that has no name because we've never experienced it. Or consider the opposite, regions where space has fewer dimensions. There might be cosmic strings or walls where space is effectively 2-dimensional or 1-dimensional. These would be edges where 1 or more dimensions end, where the universe becomes flatter, simpler, more constrained. Approaching such a boundary, you might feel yourself being squeezed, compressed, unable to move in directions that are disappearing. It would be like a 3-dimensional being trying to enter a 2-dimensional painting, possible only by giving up something essential about your 3-dimensional nature. The universe might also have regions with different physical laws, and the boundaries between these regions would be another kind of edge. The constants of nature, the speed of light, the strength of gravity, the masses of elementary particles, might not be constant throughout all of space. There could be domains where physics works differently, where atoms can't form, or where they form but follow different rules. The edges between domains would be phase boundaries, like the surface between ice and water, but for the fundamental structure of reality itself. We might be living in one such domain without knowing it. What we think of as universal physical laws might be local ordinances, valid in our region of space but not everywhere. If we could travel to the edge of our domain, we might see the laws of physics gradually changing, constants shifting, new forces emerging while familiar ones fade away. Matter itself might become impossible as we know it, replaced by something else, some other form of organization we can't imagine because it doesn't exist in our physics. Quantum mechanics adds another layer of strangeness to possible cosmic shapes. In quantum field theory, virtual particles constantly pop in and out of existence, even in empty space. This quantum foam, as it's called, might have structure on the tiniest scales, creating a kind of graininess to space itself. At the Planck scale, about 10 or 35 meters, space might not be smooth, but might have a complex topology, full of tiny wormholes and bubbles and edges that appear and disappear in quantum fluctuations. If the universe is quantum, mechanical all the way up, then its shape might be in superposition, existing in multiple configurations simultaneously until observed or measured in some cosmic sense. The edge might be both there and not there, the universe both finite and infinite, until something, perhaps our observation, perhaps some other cosmic process, collapses the wave function and decides which shape is real. We could be living in a Schrödinger's universe, its topology uncertain until the box is opened. There's even the possibility that the universe's shape is influenced by consciousness or observation in ways we don't understand. Some interpretations of quantum mechanics suggest that observation plays a fundamental role in determining reality. If consciousness is somehow basic to the universe, rather than emergent from it, then the act of wondering about edges, of imagining boundaries, might actually influence whether and where they exist. The universe might be shaped partly by our expectations, our observations, our collective imagination. This isn't mysticism, but a serious if speculative area of physics and philosophy. The measurement problem in quantum mechanics, the question of how and why quantum superpositions collapse into definite states, remains unsolved. Some physicists think consciousness might play a role, that the universe might require observers to make it real in some sense. If this is true, then by imagining edges, by searching for boundaries, we might be participating in the universe's ongoing self-creation, helping to determine its shape through our curiosity about what shape it has. As we float here at our imagined edge, hand still extended toward that ultimate boundary, we can appreciate how much stranger the universe might be than our initial simple picture of a cosmic box or sphere. It might be a torus, a Klein bottle, a bubble, a fractal, a patchwork of different dimensions and different physics. It might have edges that exist in higher dimensions, edges that can never quite be reached, edges that appear and disappear in quantum fluctuations, edges that we create by looking for them. And perhaps strangest of all of these possibilities might be true simultaneously in different regions or at different scales. The universe doesn't have to have just one shape. It could be a hybrid, a chimera, different things in different places or when viewed in different ways. What looks like an edge from one perspective might be a connection from another. What seems finite from inside might be infinite from outside. What appears to be a boundary might be a bridge. This multiplicity of possible shapes, this wealth of ways the universe might be configured, makes our imagined journey to the edge even more poignant. We're not just travelling to a boundary, but exploring what boundaries mean, what shapes are possible, what it means for something to have or not have edges. Every possibility we consider expands our conception of what the universe might be, makes it stranger and more wonderful than we imagined when we began this journey. The edge we're approaching might not be a simple boundary, but something far more exotic. A dimensional shift, a phase transition, a quantum superposition, a fractal recession, a topological twist. Or it might be all of these at once or none of them, or something we haven't imagined yet because our minds, evolved to navigate the simple spaces of Earth's surface, aren't equipped to fully grasp the true shape of the cosmos. But that's part of the beauty of this exploration. We're pushing against the limits not just of space, but of imagination, using mathematics and physics and pure wonder to explore possibilities that no human will ever experience directly. We're touching edges with our minds that our bodies can never reach, exploring shapes that exist only in equations and dreams, discovering that the universe might be far stranger than we ever dared to imagine. And now, after all our journeying, after crossing the unimaginable vastness of space and contemplating the strange possible shapes of existence, we arrive at the moment we've been moving towards since we first asked our impossible question. Your hand, or the idea of your hand, or the projection of your consciousness that serves as a hand in this realm of imagination, hovers just inches from the edge of everything. The boundary waits with infinite patience, as it has waited since the beginning of time, or perhaps since before time, or perhaps it has only just come into existence in response to your approach. Time means something different here, at the edge of all things where the usual rules have begun to soften and blur. What does it feel like, this moment before contact? There's a tingling that isn't physical, because you have no physical form here, so far from any world where bodies make sense. It's more like the feeling of anticipation itself, distilled to its essence, the universe holding its breath as one of its own creations prepares to discover its ultimate limit. You are about to do something that may be impossible, that probably is impossible, but that matters less than the reaching, the wondering, the gentle courage it takes to extend yourself toward the absolute boundary of existence. The edge itself seems to respond to your presence, though perhaps that's just your imagination creating patterns in something that has no patterns, no characteristics that human minds can truly grasp. It might shimmer, or it might be perfectly still. It might be warm or cold, though temperature has no meaning here. It might be solid or permeable, though solidity requires matter, and matter might not exist at the edge in any form we understand. All you know is that it's there, waiting, the final frontier that defines the universe by being what the universe is not. You move your hand forward slowly, so slowly, partly to savour this unprecedented moment and partly because some deep instinct warns you to be careful, to be respectful of this ultimate boundary. The distance closes, an inch, a centimetre, a millimetre, measurements that mean nothing at cosmic scales but everything to the human mind that needs familiar units to understand experience. And then, finally, after a journey that has taken us across billions of light years in imagination, your fingertips make contact with the edge of the universe. The sensation is unlike anything that exists in normal experience, yet somehow you have words for it, metaphors that approximate the unapproximable. It feels like touching the surface of still water, but water that exists in more dimensions than 3, water that remembers every drop that has ever been part of it. It feels like the static electricity before a storm, but gentle, welcoming, as if the edge recognizes you as part of what it contains. It feels like touching a mirror, but one that reflects not light, but existence itself, showing you the universe from a perspective impossible to achieve from within. Through your fingertips, or through whatever part of your consciousness is making this contact, you sense something vast and profound. The edge is not a wall but a membrane, not a barrier but a definition. It doesn't keep the universe in so much as it allows the universe to be, to have shape and form and meaning. Without this boundary, the universe would be incomplete, undefined, like a song without an ending or a story without a final word. The edge is necessary, you realize, not as a limitation but as a completion, the final stroke that makes the cosmic artwork whole. As you maintain contact with the edge, you begin to perceive things that shouldn't be perceivable, to understand things that can't quite be put into words. You sense the entirety of the universe behind you, every galaxy, every star, every world, every life that has ever existed or ever will exist. It's all there, present in some way at the boundary, as if the edge contains a complete record of everything within it. You can feel Earth, impossibly far away, that tiny blue world where your physical body lies sleeping, dreaming this dream of edges and contact. You can sense every human who has ever wondered about the cosmos, every eye that has turned toward the stars, every mind that has asked, what if? But you also sense something else, something unexpected. The edge is not one-sided. There is something beyond it, though beyond is the wrong word because it implies space, and what's beyond the edge might not be space at all. It might be other universes, infinite in number, each with their own edges, their own boundaries, their own versions of you perhaps, touching their own edges and sensing your presence across the impossible divide. Or it might be something more fundamental than universes, the source from which all universes arise, the infinite potential that becomes finite actual through the definition of edges and boundaries. The contact deepens, and you realize that touching the edge is not a one-way experience. The edge is touching you back, learning about you as you learn about it. Through you, the universe is discovering its own boundary, using consciousness, that strange emergent property of matter and energy, to explore its own limits. You're not separate from the universe touching something outside it. You're the universe's way of touching itself, of knowing itself, of defining itself through the act of discovering where it ends. This realization brings with it a profound sense of peace. All the anxiety about meaning and purpose, about our tiny lives in a vast cosmos, dissolves in the understanding that we are not accidents or afterthoughts, but essential components of the universe's self-discovery. Every conscious being, everywhere in the cosmos, is part of this same process, reaching out in their own ways to touch edges, to find boundaries, to discover what is and what isn't, what can be and what cannot. The edge begins to reveal more of its nature to you, or perhaps you're becoming more capable of perceiving what was always there. It's not uniform, not the smooth surface your imagination might have expected. It has texture, patterns, what might be called geography if geography could exist without land. There are areas that feel denser, more definite, and areas that are almost not there at all. Places where the boundary between existence and non-existence is gossamer thin. These variations might correspond to something about the universe's structure, perhaps denser regions where galaxy clusters approach the edge, or thinner regions corresponding to the great voids, or they might represent something else entirely, patterns in dimensions we can't perceive, structures in aspects of reality we haven't discovered yet. You move your hand along the edge, feeling these variations, reading the universe's autobiography written in the texture of its boundary. Each irregularity tells a story. Here, perhaps, the echo of cosmic inflation, frozen into the edge like ripples frozen in ice. There, maybe the scar of some primordial event, something that happened before the Big Bang or outside our understanding of time. The edge is a record, a memory, a map of everything that has contributed to making the universe what it is. As you explore, you notice that the edge seems to respond to your attention. Where you focus, it becomes more detailed, more complex, as if your observation is increasing its resolution, bringing it more fully into being. This might be an illusion, your mind creating patterns where none exist, or it might be something profound about the relationship between consciousness and cosmos. Perhaps edges, boundaries, definitions require observers to be fully real. Perhaps the universe needs us as much as we need it, each defining the other through the act of observation and experience. Time has become strange here at the edge. You might have been touching it for seconds or centuries. There's no way to tell and perhaps no difference. Past and future seem to converge at the boundary, all moments existing simultaneously in an eternal now that encompasses the universe's entire history. You can sense the Big Bang, still happening in some sense at the edge, the initial expansion that created space and time still reverberating through the boundary. You can sense the far future too, the universe's eventual fate encoded somehow in the structure of its edge, whether it will expand forever, cooling and dimming until only black holes remain, or whether it will eventually contract, the edge drawing inward until everything converges again to a point. The edge whispers secrets to you, not in words, but in direct understanding that bypasses language and thought. You learn things that can't quite be retained once you leave this place, truths too large for human minds to hold. The nature of consciousness, the purpose of existence, the answer to why there is something rather than nothing. It's all there, accessible through the edge, but most of it will fade like dreams fade, leaving only impressions, feelings, the memory of having known without the knowledge itself. One thing you understand clearly though, and this understanding will remain. The edge is not a flaw or a limitation, but a gift. It gives the universe definition, shape, meaning. An infinite, edgeless universe would be in some sense incomplete, unable to know itself because there would be no boundary to create perspective, no outside from which to see the inside. The edge, whether real or imagined, whether physical or conceptual, is what allows the universe to be a universe rather than just an endless expanse of possibility. You also understand that touching the edge changes you. Not physically. Your body remains safe on Earth, untouched by this imaginary journey. But something in your consciousness has shifted, expanded, incorporated the experience of touching the ultimate boundary. You have become, in a small way, larger on the inside, more capable of containing paradox and mystery. The edge has given you a gift, the ability to be comfortable with limits while simultaneously understanding that limits can be transcended through imagination, through wonder, through the simple act of asking, what if? As you prepare to withdraw your hand to step back from the edge and begin the long journey home, you feel a reluctance to break contact. Not because the edge holds you, but because this moment of connection feels important, historic even, though no history will record it. You're possibly the first consciousness to imagine this particular moment in exactly this way, to touch the edge with exactly this combination of wonder and peace and understanding. In the vast story of the universe, this moment is unique, irreplaceable, yours alone while also belonging to the cosmos as a whole. But you know you cannot stay. The edge is not a destination but a turning point, a place to touch briefly, before returning to the world within. Your life, your loved ones, your small but significant existence on Earth calls you back. And perhaps that's another gift of the edge. It reminds us that the journey home is just as important as the journey out, that returning with new understanding is the completion of exploration, not its abandonment. Slowly, gently, you withdraw your hand from the edge. The contact breaks, but something remains, a connection, a memory, a change in how you understand your place in the cosmos. The edge recedes, or you recede from it, beginning the long drift back through the darkness toward the distant light of home. But you carry something of the edge with you now, a fragment of that ultimate boundary that will forever change how you see the universe and your place within it. As you float away, you look back one last time at the edge of everything. It's already becoming hard to see, fading into the conceptual distance, becoming more idea than experience. But you know it's there, waiting patiently at the limit of all things, defining the universe through its presence, complete and mysterious and perfect in its own way. And you know too that in some sense you'll always be touching it, because once you've reached the edge of everything, part of you remains there forever, a gentle hand extended toward the boundary of existence, forever making that first soft contact with the impossible. The journey back from the edge is not a retreat, but a return, carrying with you the strange peace of having touched the boundary of everything. As you drift back through the cosmic vastness, past the last lonely galaxies, through the great voids, toward the warm spiral of the Milky Way, toward the small yellow star we call the Sun, toward the blue marble of Earth, you begin to notice something profound. The edge you touched out there, at the limit of existence, has echoes everywhere, reflections and parallels in scales both cosmic and intimate. Every boundary you encounter on the journey home reminds you of that ultimate boundary, and you begin to understand that edges are not just features of the universe, but fundamental to how we experience and understand existence itself. Consider the edge of our solar system, that fuzzy boundary where the sun's influence fades and interstellar space begins. It's not a sharp line, but a gradual transition, the solar wind growing weaker, the magnetic field becoming tenuous, until finally you're in the space between stars. The Voyager spacecraft crossed this boundary years ago, carrying messages from Earth into the cosmic dark. They touched an edge for us, these small ambassadors of human curiosity, and in doing so helped us understand that boundaries can be crossed, that edges are not walls but doorways to whatever lies beyond. Or think about the edge of Earth's atmosphere, that thin layer of air that stands between us and the vacuum of space. Every astronaut who has crossed this boundary describes it as a transformative experience. They leave Earth as representatives of nations and return as citizens of a planet, having seen the edge that defines our world, the fragile boundary that makes life as we know it possible. The edge of our atmosphere is like the edge of the universe in miniature, a boundary that defines and protects, that creates an inside where complexity and consciousness can flourish. But edges exist at every scale, not just in the vastness of space. Your own body is defined by edges, the boundary of your skin separating you from everything that is not you. Yet this edge is not absolute. You exchange matter and energy with your environment constantly, breathing, eating, radiating heat, shedding skin cells, absorbing sunlight. Your boundary is permeable, dynamic, more like a pattern that maintains itself through constant exchange than a fixed barrier. You are less like a solid object with definite edges and more like a whirlpool in the flow of matter and energy, a temporary arrangement that maintains its form while its substance constantly changes. Even your consciousness has edges, though they're harder to define. There's the edge between waking and sleeping, that fuzzy boundary you cross twice each day, sometimes remembering the journey, sometimes not. There's the edge of attention, the limit of how much you can be aware of at once. There's the edge of memory, the boundary between what you can recall and what is lost to time. And there's the edge of self, that mysterious boundary between you and not you, between the observer and the observed, between the universe looking and the universe being looked at. These personal edges echo the cosmic edge in profound ways. Just as the universe might need its edge to have definition and meaning, you need your edges to exist as an individual. Without the boundary of your skin, you would dissolve into your environment. Without the edges of your consciousness, you would have no identity, no sense of self distinct from the world around you. Edges create identity, whether for a person or a universe. They say, "This is what I am," by defining, "This is what I am not." Think about the edges in your daily life, the boundaries that structure your experience. The walls of your home create an edge between private and public, between your space and the world's space. The beginning and ending of your workday create edges in time, boundaries between different modes of being. Relationships have edges too, the boundaries between friend and stranger, between intimate and casual, between self and other. These edges are constantly negotiated, sometimes sharp, sometimes blurred, always essential to how we navigate our social universe. There are temporal edges in every human life, boundaries in time that define our personal stories. Birth is an edge, the boundary between non-existence and existence, at least from our individual perspective. Death is another edge, the boundary we all approach but cannot see beyond. Between these ultimate personal boundaries are countless smaller edges: the end of childhood, the beginning of independence, the transitions between life phases that mark our growth and change. Each of these edges is like a smaller version of the cosmic edge, a boundary that defines what we are by marking a transition to what we are becoming or leaving behind. Consider how we approach these personal edges with the same mixture of curiosity and trepidation that we imagined approaching the universe's edge. A child standing at the edge of adolescence, sensing changes coming, but not quite understanding what lies ahead. A person at the edge of a major life decision, knowing that stepping forward will change everything but not knowing exactly how. Someone at the edge of death, approaching that ultimate personal boundary with whatever courage and grace they can muster. These are all echoes of our cosmic journey, smaller scales of the same fundamental encounter with limits and transitions. The edges in our lives are teaching tools, just like the cosmic edge we imagined. They show us where we are and where we might go. They challenge us to grow, to expand, to transcend our current limitations. Every edge we encounter and cross makes us larger, more experienced, more capable of dealing with future edges. The child who bravely starts their first day of school is practicing for every future transition. The person who survives loss and grief has touched an edge and returned with hard-won wisdom. We are all edge explorers in our own ways, constantly pushing against the boundaries of our experience. But edges can also be places of rest, not just challenge. The edge of sleep is where we retreat each night, a boundary that protects us from the constant demands of consciousness. The edge of our capabilities is where we learn to accept help, to recognize that we are not infinite, that limitation is not failure but humanity. The edge of understanding is where wonder lives, where mystery begins, where we can release the need to know everything and simply marvel at the vastness of what we don't know. This is perhaps what the cosmic edge was trying to teach us, that boundaries are not just limitations but gifts. They create definition, meaning, identity. They give us something to push against, something to transcend, something to define ourselves in relation to. Without edges, there would be no growth, because growth requires something to grow beyond. Without boundaries, there would be no journeys, because journeys require destinations, even if those destinations are ultimately unreachable. Think about how artists use edges in their work. A painting's edge, the frame, defines what is included and what is excluded, creating a bounded space where meaning can emerge. A story's edge, its beginning and ending, creates the container within which narrative can flow. A piece of music has edges too, the silence before the first note and after the last, the boundaries that make the music possible by distinguishing it from not music. Artists understand that edges are creative tools, not just limitations but essential elements of composition. Scientists work with edges too, though they might call them by different names. The edge of the observable, the limit of measurement, the boundary between known and unknown. Every scientific instrument has edges to its capabilities, ranges beyond which it cannot detect or measure. Every theory has edges, domains beyond which it breaks down or becomes inapplicable. Science progresses by pushing against these edges, extending them, sometimes discovering that what seemed like an edge was just a horizon, with more universe beyond. The edge between life and non-life is one of the most profound boundaries we encounter. What makes a collection of molecules alive while another collection is not? Where exactly is the edge between chemistry and biology? Scientists study viruses that exist at this edge, neither fully alive nor fully dead, challenging our definitions and forcing us to reconsider what we mean by life. Perhaps life itself is not a binary state, but a spectrum, with edges that are more gradient than boundary, more transition than wall. Consciousness presents another mysterious edge. Where does consciousness begin in the development of a brain? When does a collection of neurons become aware? Is there a sharp edge between conscious and unconscious? Or is it a gradual emergence like dawn breaking slowly over a landscape? And what about the edges of consciousness in other species, in artificial intelligences, perhaps in the universe itself? These are edges we're still exploring, boundaries we're still trying to map. Cultural edges shape our collective experience just as personal edges shape our individual lives. The boundaries between nations, between languages, between traditions create the diversity that enriches human experience. Yet these edges can also divide us, creating us versus them dynamics that lead to conflict and misunderstanding. Learning to see cultural edges as permeable membranes rather than walls, as places of exchange rather than exclusion, is one of humanity's ongoing challenges and opportunities. Even our technologies create and encounter edges. The edge of the possible, the boundary between what we can build and what remains beyond our capabilities. The edge of the digital and physical worlds, increasingly blurred as technology becomes more integrated into our daily lives. The edge of privacy and transparency, constantly renegotiated as we share more of ourselves online. These technological edges are new kinds of boundaries, ones our ancestors never had to navigate, yet they echo the same fundamental questions about identity, limitation, and possibility. The climate crisis represents humanity encountering a planetary edge, the boundary of what Earth's systems can sustain. We're learning, perhaps too slowly, that there are edges to growth, limits to extraction, boundaries to what we can take from the world without giving back. This is perhaps the most important edge we face as a species, the edge of sustainability, the boundary between a livable future and catastrophic change. Like the cosmic edge, it requires us to understand our place in a larger system, to see ourselves not as separate from but as part of the environment that sustains us. In our relationships, we constantly navigate edges, the edge between self and other, between maintaining individual identity and merging with another, the edge between holding on and letting go, between love and loss, between connection and independence. Every relationship is a negotiation of boundaries, a dance of approaching and retreating from various edges. The healthiest relationships are those where edges are respected but permeable, where boundaries create safe spaces for both togetherness and autonomy. Even this moment, as you lie listening to these words, you exist at multiple edges simultaneously. The edge between today and tomorrow, if it's late at night where you are. The edge between waking and sleeping, as these ideas wash over you like gentle waves. The edge between your daily life and this cosmic journey we've taken together. You're always at some edge, always in transition, always becoming something slightly different from what you were a moment ago. The edge of the universe that we imagine touching has shown us that edges are everywhere, at every scale, in every aspect of our experience. From the cosmic to the quantum, from the personal to the planetary, edges define and shape our reality. They are not flaws in the fabric of existence, but essential features, the seams that hold everything together, while also creating the possibility for growth and change. As we prepare to complete our journey, to return fully to the familiar world of our daily lives, we carry with us this new understanding of edges. They are not just boundaries, but opportunities. Not just limitations, but definitions. Not just endings, but also beginnings. Every edge we encounter in our lives, whether it's the edge of our capabilities, the edge of our understanding, or the edge of our time on Earth, is a chance to touch something larger than ourselves, to participate in the universe's ongoing exploration of its own boundaries. The cosmic edge we imagined, whether it exists in physical reality or only in our contemplation, has given us a gift. The ability to see all edges as related, all boundaries as part of the same fundamental structure of existence. When you wake tomorrow and face the edges of your day, the transition from sleep to waking, from home to world, from one task to another, you might remember the ultimate edge we touched tonight and understand that every boundary you cross is a small echo of that cosmic encounter. Every limit you meet is a reminder that edges are what make existence possible. And so, we return to where we began, but not unchanged. The question that started our journey, what if the universe had edges you could touch, remains with us. But it has transformed from a simple wondering into something deeper, richer, more nuanced. We have travelled in imagination to the furthest reaches of existence, extended our hand toward the ultimate boundary, felt the strange peace of touching what might be the edge of everything. And now, as we settle back into the familiar comfort of our earthly existence, we must ask, what does it all mean? What do we do with this experience, this imagined contact with the cosmic boundary? The truth, which has been with us all along but perhaps only now becomes clear, is that the edge of the universe, whether it exists as a physical boundary or lives only in our contemplation, was always more about the journey than the destination. It was an invitation to wonder, a framework for exploring not just the cosmos but our place within it, our relationship to limits and infinities, boundaries and boundlessness. The edge we sought was as much inside us as outside, as much about consciousness as about cosmology, as much about meaning as about measurement. Science tells us, with increasing confidence, that the universe probably doesn't have edges in any conventional sense. It might be infinite, extending forever in all directions without boundary or limit. Or it might be finite but unbounded, curved in such a way that you could travel forever without finding an edge, like an ant on a sphere or a cosmic being in a higher dimensional manifold. The observable universe has a horizon, yes, but that's a limit of vision, not a wall in space. Beyond what we can see, there is almost certainly more universe, perhaps infinitely more, perhaps finite but so vast that the distinction hardly matters on any scale we can comprehend. And yet, the absence of physical edges doesn't diminish the value of our imaginary journey. If anything, it makes it more precious. In a universe that might have no boundaries, we created one with our imagination. We gave form to the formless, definition to the infinite, edges to the edgeless. This is what consciousness does. It creates meaning, structure, narrative from the raw material of existence. The edge we touched was real in the only way that ultimately matters. It was real in experience, real in contemplation, real in its effect on how we understand ourselves and our cosmos. Consider what we've learned from our journey to the imagined edge. We've discovered that the universe is vast beyond comprehension, yet we are intimately connected to all of it through the atoms in our bodies, forged in the hearts of dying stars. We've learned that boundaries exist at every scale, from the quantum to the cosmic, and that these boundaries are not flaws but features, essential elements that create identity and enable change. We've understood that consciousness itself might be how the universe explores its own limits, touches its own boundaries, discovers what it is through beings like us who wonder about what it might be. The edge that never ends is not a paradox but a profound truth about the nature of exploration and understanding. Every boundary we reach reveals new boundaries beyond it. Every question we answer generates new questions. Every edge we touch shows us that there are more edges to discover, more limits to transcend, more boundaries to explore. This is not frustrating but liberating. It means the journey never has to end, the wonder never has to cease. The exploration can continue as long as consciousness exists to do the exploring. Think about how this applies to human knowledge. Every scientific discovery pushes back the edge of the unknown, but it also reveals new unknowns we didn't even know existed. When we discovered atoms, we thought we'd found the fundamental building blocks of matter, only to discover subatomic particles. When we found those, we discovered quarks and leptons. Now we suspect there might be strings or loops or something else entirely at an even smaller scale. Each answer opens new questions. Each edge reveals new edges. Each boundary crossed shows us new boundaries we hadn't imagined. This is true in our personal lives as well. Every skill we master reveals new skills to learn. Every experience we have opens possibilities for new experiences. Every person we meet shows us new aspects of human nature we hadn't encountered before. Every edge we cross in our personal development reveals new edges we couldn't see from our previous vantage point. Growth is not about reaching a final destination, but about continually discovering new frontiers, new edges to approach and explore. The universe itself seems to embody this principle of endless boundaries. As it expands, it creates new space, new possibilities, new edges. The cosmic horizon that limits our observation moves outward as time passes, revealing new galaxies that were previously beyond our view. But it also recedes from us, as accelerating expansion carries distant galaxies beyond the horizon, creating new edges of observability. The universe is simultaneously revealing and concealing itself, showing us more while also creating new mysteries, new boundaries to wonder about. Dark matter and dark energy represent edges of our current understanding, boundaries where our knowledge stops and speculation begins. We know these phenomena exist. We can see their effects on galaxies and cosmic expansion, but we don't know what they are. They are edges waiting to be explored, boundaries that future generations might cross, revealing new edges we can't currently imagine. The history of science is a history of approaching edges, touching them, passing through them, and discovering new edges beyond. Even if the universe is truly infinite, truly edgeless in a physical sense, it still has conceptual edges, philosophical boundaries, limits to what can be known or understood. There are questions that might not have answers, or might have answers our minds aren't equipped to comprehend. What came before the Big Bang? Why does anything exist at all? What is consciousness really? These are edges of a different kind, boundaries not of space but of knowledge, not of physics but of philosophy. The edge we imagined touching was all of these edges at once: physical, conceptual, philosophical, personal. It was the edge of the universe and the edge of understanding, the boundary of space and the boundary of imagination. By touching it in our contemplation, we touched something essential about the human condition, our need to explore, to push boundaries, to reach for what might be unreachable. This need is perhaps what makes us most human, this refusal to accept limits without first testing them, this drive to touch edges even if they exist only in our imagination. As you lie there, perhaps drifting closer to sleep, carried by these thoughts of edges and infinities, you are participating in something ancient and ongoing. Humans have always wondered about boundaries, always imagined what lies beyond the horizon, always reached for edges they couldn't quite touch. The child who wonders what's beyond the sky, the ancient philosopher contemplating the nature of existence, the modern cosmologist mapping the large-scale structure of the universe, all a part of the same tradition, the same cosmic reaching that brought us to the edge tonight. And perhaps this is the ultimate meaning of our imagined edge. It reminds us that we are the universe's way of contemplating itself, of exploring its own boundaries, of wondering about its own nature. Through us, the cosmos touches its own edges, real or imagined. Through our consciousness, it discovers what it means to have limits and to transcend them through imagination. We are not separate from the universe looking at it from outside. We are the universe looking at itself from within, creating edges through the act of looking for them. The peaceful feeling that comes from accepting this, that we are part of something vast and mysterious and beautiful, that our small lives are essential components of the universe's self-discovery, is perhaps the greatest gift of our imaginary journey. We don't need to physically touch the edge of the universe to understand our place within it. We don't need to solve every mystery to appreciate the beauty of mystery itself. We don't need to reach every boundary to know that reaching for boundaries is what gives life meaning. Living with mystery, with unanswered questions, with edges we can't quite touch, is not a limitation but a gift. It means there's always more to discover, always new territories to explore, always fresh wonders to encounter. If we knew everything, if we had touched every edge and crossed every boundary, what would be left to drive us forward? The edge that never ends is the gift that keeps giving, the mystery that keeps inspiring, the question that keeps us questioning. As our meditation draws to its close, as we prepare to release these cosmic thoughts and drift into sleep or back into the rhythms of daily life, we can carry with us the peace that comes from touching the untouchable, from imagining the unimaginable, from reaching for edges that may or may not exist. We have been to the boundary of everything and back, not in body but in spirit, not in reality but in imagination, which might be its own kind of reality. The universe continues its expansion around us and within us. Galaxies drift apart in the darkness. Stars are born and die. Planets spin in their orbits. And on at least one of those planets, consciousness has emerged and wondered about edges, about boundaries, about the limits of existence. This wondering is not separate from the universe, but part of its fundamental nature, as essential as gravity or electromagnetism. The universe wonders about itself through us, touches its own edges through our reaching, discovers its own nature through our discoveries. Tomorrow, when you wake, the familiar edges of your daily life will be there, the boundaries of your room, your schedule, your responsibilities. But perhaps they'll seem different now, connected to something larger, part of the same cosmic pattern of boundaries and transcendence that we've explored tonight. Every edge you encounter, from the mundane to the profound, is related to that ultimate edge we imagined. Every boundary you cross in your daily life is a small echo of our cosmic journey. The question we began with, what if the universe had edges you could touch? has no definitive answer, and that's perhaps the most beautiful answer of all. It means the question remains alive, remains powerful, remains an invitation to wonder, whether the universe has edges or extends forever, whether boundaries are real or constructed, whether we can ever truly touch the limits of existence. These uncertainties are not problems to be solved, but gifts to be treasured. They keep us humble, curious, alive to possibility. In the end, we discover that the edge we sought was never really about finding a boundary in space. It was about discovering the boundaries of our own understanding and having the courage to reach beyond them. It was about recognizing that we are finite beings capable of contemplating infinity, limited creatures who can imagine the unlimited. It was about understanding that every edge we approach, whether cosmic or personal, is an opportunity for growth, for wonder, for connection with something larger than ourselves. The universe may or may not have edges you could touch, but you have touched something profound in imagining the possibility. You have participated in the ancient human tradition of wondering, of reaching, of refusing to accept the boundaries of the known without first exploring them. You have added your consciousness to the cosmic effort of self-discovery, your imagination to the universe's attempt to understand itself. As sleep approaches, or as you return to waking life, you can rest in the knowledge that you have been on a journey that matters, even if it happened only in imagination. You have touched the edge of everything, felt the boundary of existence, discovered that limits and limitlessness are both part of the same cosmic dance. The edge you touched will always be with you now, not as a memory of something that happened, but as an expansion of what's possible, an enlargement of your inner universe that mirrors the vast universe around us. The stars continue their slow wheel overhead, whether you can see them or not. Galaxies drift in the darkness, separated by distances that dwarf comprehension. And somewhere, at a distance that might be finite or infinite, there might or might not be an edge to it all. But what matters is not whether that edge exists, but that we can imagine it, reach for it, touch it with the fingertips of thought. In that reaching, in that touching, we become more than we were, larger on the inside, more capable of containing the vast mystery of existence. This is the edge that never ends, the boundary between known and unknown that we approach but never fully cross, the horizon that recedes as we advance, the mystery that deepens as we explore it. It's the edge between self and universe that turns out not to be a boundary at all, but a connection, a place where consciousness and cosmos meet and recognize themselves in each other. It's the edge between sleeping and waking where we spend our lives, always on the boundary between dreams and reality, between imagination and experience. And so we end where we began, with a question that has no answer but generates infinite wonder. What if the universe had edges you could touch? We have touched them in the only way that matters, with imagination, with wonder, with the gentle courage to reach for what might not exist. And in that touching, we have discovered something that definitely does exist. Our own capacity for cosmic thought, for universal wonder, for touching edges that exist at the boundary between mind and mystery. Rest now, knowing you have been to the edge of everything. Rest knowing you have touched the boundary of existence, even if only in dreams. Rest knowing that the universe is vast and mysterious and beautiful, and that you are part of it. Not a small part, but an essential part. The part that wonders, that reaches, that touches edges and returns to tell the tale. The edge will always be there, waiting, patient as the cosmos itself, ready whenever you're ready to reach for it again. The universe might have edges, or it might go on forever. Either way, it contains consciousness capable of imagining both possibilities, and that consciousness is you. In your wondering, the universe wonders. In your reaching, the universe reaches. In your touching of imagined edges, the universe discovers something real about its own nature. You are not just in the universe. You are the universe, temporarily organized into a pattern capable of contemplating the whole. And that might be the most wonderful edge of all, the boundary between the cosmos and its own awareness, forever touching itself through beings like us who dare to imagine edges and reach for them with minds made of stars,